2 calls. So one call was in 2014. Those projects have started in the beginning of 2015. So they are running for 2 years now. Some, as for us, for example, are about to be completed already. We have impressive results already. So these are the ones you're going to see today. Then we have also invited the ones from 2016 call. They have just started or are just about to start. also the Digitizing the European Industry initiative, which of course is now going hand in hand and influencing very much the future program too. And I think you have to talk at the microphone. Okay, so the word is yours. And if you want to switch it up.
Thank you very much for the kind introduction. Yeah, welcome to this consultation event. I think it's great that you come in such a big number. These events are always very interesting because you all run projects and you have interesting results. This is one of the opportunities where you can exchange and network, show what you have done. So this is very good. And I'm grateful to the organizers from SmartCPS and TAM4CPS that you did this exercise, that you brought also people, how should I say, I try to avoid the word, we have calls, and when we do calls, a certain group of people answer to the calls. And you have here reached out to SCORPIUS, for example. So it's very good. I welcome the SCORPIUS people here. Thanks for coming as well. There will be talks about Artemis, so that refers to the Excel program, which is again another program. Yeah, and so this exchange is very good. I wanted to say also that what has happened actually in our unit, in our activities, that we do more than just genuine research funding. The research funding, you know, since decades, the Commission has always been doing. But since Horizon 2020 started, we also try to help setting up a framework which is good for innovation in Europe, which helps to keep jobs here. And we do this using our instruments. You know the instruments, but what is maybe not so well known is the ideas that we have picked up from the stakeholders that drive these activities. So the first thing, if you want to do a policy initiative, is that you invent a nice name. The nice name is digitizing European industry. Digitizing digital transformation. So, but what is this about? When I try to elaborate a bit in 15 minutes, that's a kind of a short version. Some of you know that there is an event in Essen, Germany, a much larger event with 600 people, and this 2 days, I think, event is dedicated totally to the digital transformation of European industry. So, if you are interested, have a look on the website. You will later see how the website, the link of the website, and look into it. So that's very interesting, I think. And I hope I can convince you why. So first of all, I start with what you know very well, the technologies that drive the digital transformation. Let's try out now the laser pointer. It works fantastic. So I think there's no doubt nobody in Europe has something against innovation in products, innovation in processes, and innovation in business models. So that's certainly a good thing. And there's now more, how should I say, more momentum. Why is this? Because there are interesting technologies around that took up speed. First, the Internet of Things, and then I want to see it here in a very broad sense. So that's connecting things, but it's also making these things intelligent. So embedded software plays a role, the sensors plays a role, that you can reach out from the cyber world to the real world, to get real data in with sensors, actuators. Very often this needs to be low power because you carry around the devices, so you have to make sure that the processing is starting at low power. Using light is very nice, so they say here. So to connect is also very important. That's the Internet of Things strand of technology. Then you have the big data. Big data means that you process data, that you analyze the data, that you aggregate the data. So the data is abundant, that's clear, but it's very difficult to make sense of it. And exactly this is what big data is about. Analytics, cloud. High performance machines are intelligent, and we want to have the machines to be intelligent. So we want to have the artifacts to be intelligent. It's certainly connected with autonomous systems. If you want to have a system to be autonomous, then exactly what if it does all the things by itself, then you need to have some intelligence. So that's the other strand of technology. It's connected with robotics, automation, with machine learning, self-driving. It goes that far in the commission that the unit robotics, who was devoted to robotics, it has a new name actually, and the second part of the name is exactly robotics and artificial intelligence. It shows that also we at the commission take this serious. Anyhow, these three technologies are the ones that drive this digital transformation. That's fine. I think that was just a reminder. The second thing which I want to stress, this is for the researchers and for the technology developers. If you think in terms of business, okay, all this is connected, we know it. If you want to really build these things, many of you are engineers, and I think the natural desire of engineers is to bring technology into reality, then I think it's good to think in value chains. And we talk about ICT, so we talk about digital value chains. Value chains means that you have, when you engineer these things and you build it, that you have to have a whole chain in place. So one player cannot do everything, what you see here on the picture. So if you start on the left, you can leave that, okay, that's the ground, the foundational building blocks, certainly the chips, the electronics, and also the computing architecture. You need software, you need connectivity technology. I think everybody knows 5G, so that's coming technology for communication. So you need all this, but if you stop here, it doesn't go that far, isn't it? Then in the very right, you have the systems that people can use. So autonomous car, this is kind of always high, how should I say, very ambitious goals. Let's see how much autonomy we will need, how much autonomy we want to have in the cars. But anyhow, that's where many are working towards. Smart factory is a very good thing to have, and which is immediately clear how it helps people and factories. Healthy aging, then it's not complete, there can be much more online platforms, energy, whatever. But these are the systems. But you cannot jump immediately from the tube to the autonomous car. There's something in between. For example, robots, so technology, machinery, AI again, artificial intelligence, big data, data analytics, cloud computing, Internet of Things. Anyhow, if you are a company, then you operate here or here, but you rarely operate at the whole thing. So this is why, if you think in terms of innovation, if you put yourself in our shoes, you have to think all of these pieces of the value chain and to create a framework where this value chain can work well together. So for you, for the researchers, it means also if you do something, I don't know, cyber-physics systems is maybe all this stuff here, a little bit here, that you know which results you need in order to do your research. And then you also know who will use and how your results will be used, so that you have the whole picture in mind. And this happens also. In microelectronics, people sit together, industry leaders, and they were thinking, who will in the future need our chips and what are they used to? So they came up with thinking about these things, and then they tried to develop a strategy that they can feed into this. The same is happening in high-performance computing. Anyhow, I want to expose you to this, that you kind of see where your research is positioned. And we from the Commission, together with member states and regions, we try to get the framework conditions right. Time not to get lost. Now I kind of look back what we have today. Oops. Okay, I didn't make the slide, but now it's complete. this program, the bulk of our money is being spent. So I see cyber-physical systems that was here in connection with Excel. And this answers already part of the question of Mike or the hint. It looks like the CPS activity funded by the Commission is shrinking. It's not true. If you look into it in combination with Excel, you see that it's even above average, the budget development. I think that's one of the messages I want to give. So here is Excel, and cyber-physical systems activities are funded here, but not only here, also in Internet of Things, certainly also in factories of the future. SCORPIUS colleagues will say something about it, what is important for manufacturing, and the others will develop, this is also a good cyber-physical system. So I think, let's see. Then robotics is certainly interesting. If you look as somebody who is interested in funding it and look at these codes, artificial intelligence, maybe also big data, high performance computing, or maybe 5G and photonics I just mentioned. And I mentioned there's cybersecurity. This is a brand new public-private partnership with significant funding, which started last year, June. Anyhow, it started mid of 2016. We were, how should I say, we heard strong voices that this is very important. That's clear, cybersecurity is important, but also the research in cybersecurity would be important. And we responded by setting up this special public-private partnership. Good. So this is what the Commission kind of offers today. And you might wonder, what has this to do with digital transformation? You just continue this and all will be fine. Yeah, the trick is, of course, I give already part of the answer. First part is, we, with the easy money, we just have a part of the funding money in Europe. So that's one thing. That we reach out to member states and to regional funding agencies to see how we can work better together, to see where synergies are. There could be share of work, simply speaking, yes. There could be stressing something which is especially important, like manufacturing. I see the colleagues smiling because they're happy. There's a strong program in industry, in all the countries, and we, the Commission, do it as well. I think it's a very good thing to do, isn't it? There might be other fields where this makes sense. So, on one slide, this is condensed everything, all the strands of activities we have in digitizing European industry. Has been launched in April last year by Commissioner Oettinger. It would lead much too far if I would go through all of this, but I just say digitizing industry are considered. So that you need new skills, that the question, you have to answer the question on the policy side, what will happen to the jobs of the workers, to the employees, how is that going to be transformed? So this is also be taken care of, but it's not a topic for today, so I will not talk about it. I will want to talk about this public-private partnership, and the heading here is strengthening leadership in key parts of the digital value chain. So public-private partnership, what industrial platforms could be, and large-scale pilots and testbeds. So this is one important activity, one of, depends how you count, but in the paper there are 5, and I want to talk exactly about this. Show the program. And I start with a kind of a vision. The vision is driven by the enormous success of the online platforms in the internet business. And you know all these platforms. This is, for example, the Android operating system, what Amazon does, Apple, and the like. And the thinking is, can something similar, if we look into the future, which we cannot, but we can try, can something similar happen it's important to think about it, because if it were, and such platform would scale like Google platform did, that's certainly something not to miss, isn't it? So, and if you speculate a bit where such platforms could be, one could first start to look at it from the sector. So manufacturing could be one, or there could be platforms in manufacturing. Let me put like this. There could be future platforms in food or in agriculture, in energy. Think of, I'm searching for the word, we have these smart meters. They are very nice, yeah. But the really nice thing is that you have a system where you as a producer of energy can sell your electricity, that you can switch on your heavily consuming devices when electricity is cheap, and all this is at the moment not working, but with IT it could work, no doubt. I don't go on all to this, but I want to say you can categorize these platforms also, you can look at them for cross-sector level. I start with components. So in microelectronics you don't have 200 different types of processors. You have just a few, so you have platforms. And it's division of labor thing, but there could be more for the new devices, photonics for example. The same for IoT, cyber-physical systems. You will certainly hear over the day something what could be done interestingly in cyber-physical systems and whether there could be platforms. Artificial intelligence, big data, and all this. So, there's platform activity. Now I narrow again down my scope. I will now play with the example of manufacturing. The remaining 5 minutes. There's this notion, this activity of Industry 4.0 around. And a well-known person, Mr. Kagermann, at least in Germany is well known, but he's a founder of SAP, and SAP everybody in the room knows. He was collecting the key challenges for Industry 4.0. So these are the challenges. According to semantics, which is talking the same language, and models, very interesting for Industry 4.0. But this is really an appeal for the academic world to think of models. This is very complicated. You cannot really, how should I say, force it. You have to be patient and to work for a long time. Then systems engineering. Very obvious. The systems of the future. What is sure that they are getting more and more complicated. And you have to have methods to deal with them. Logistics is very important. If you think of value chains, you have to connect. And what is also interesting, the different players, they need to be able to foresee what is needed, how much do I need to produce tomorrow or the next week, and what parts do I have. In a moment, there's always a human being who has to click into order. If you can automate these ordering system and contracting and establish such value networks, this would be very good, isn't it? And all the machines and the systems should become more and more autonomous, but they will never be 100% autonomous. This is also clear, because the human being wants to be in control. Then you have to think about how to organize these interactions of human beings and production systems. So these are, one can discuss it, but these are certainly interesting challenges for Industry 4.0. That's the desired outcome. And what's happening on the ground, if you want so, there are already a couple of platforms. They all have to do with manufacturing, and they're industry-driven. There, of course, is a slide the Commission likes to show with many logos. You see there's a big involvement. But I want to guide you first the categories. So all these are existing platforms. It's not so much vision. First I talked about vision. These are existing platforms, and they are different maturity. And it's interesting to see whether they are vertical in one sector. These are in a certain sector, and how they are led. They can led by one company, say extreme. They can led by a group. They can led by a whole community. RAMI, reference architectures. These are certainly a community-led initiative. Also what we have funded, the FIWARE, is community-led in vertical sectors. Then cross-sector activity would be, this is standing for industrial data space. This is for safety critical systems, S3P, which started in France, which is getting more and more traction. I want to mention Internet of Things, even not being from the unit Internet of Things, but the colleagues are doing good work in establishing this forum. You know it. There's also Internet of Things calls. I encourage you to study carefully what they're calling, because you will see that you can apply for it in many cases. Crystal is a large project which deals on interfaces between models which you need in manufacturing, runs in the Excel program. There's Arrowhead, and I've seen there's also Jerke in the room. We shook hands. Jerke, we talked about Arrowhead, so I don't need to do it. It's a project, a very large project on manufacturing, and so on. I think I stop here. I just wanted to mention that there are also proprietary platforms. In many cases, you as an innovator, you are confronted that the proprietary platform is in place, and then your creativity would go into what is putting something on top of this platform. And here are some lists. Good. This is my large slide with new content, if you want so. I wanted to just show in one slide what do we want to do on top of our research funding. Well, we want to do two things. We want to reach out to the member states and to the regions to do something with them together. Coordinate our programs. First thing. Second thing is we want to establish test beds and large-scale pilots in cooperation with industry. How could it work? On a PowerPoint slide. So if we start with what is in the center, again to remind you, the idea is to go for such a platform. If people tell us there's an important opportunity in manufacturing, what could be done? One could fund activities, we could fund them from the European Union, Manufacturers of the Future, Inspire and Excel, where such platforms would be developed and would be integrated. Because you have to put pieces together. You need to spend money and effort to integrate. And then you would strengthen interoperability and you would create a framework. But this would never fly on its own. You need also experiments. And I don't know where to start. Maybe I start here. We talk about transport. So let's see in an auto factory one would do experiments which are close to reality. One would try out technologies. So that's the new thing if you want. Then one would also have big experiments in another automotive lab. Small companies also need to be involved. Essen, 800 people registered, and let's see how many really will come. The main objective is to show to the world that Commission does something with member states. So Essen, the Essen event is organized, co-organized by the German Ministry for Research and also for economy. And there will be policy decision makers, there will be people from industry, there will be panels with high-ranking industry leaders, and there will be also workshops on different sectors. So, for example, in health, in automotive, in manufacturing, and there will be also reporting taking place. What has been achieved so far? Where are we? Is there any willingness of the member states to cooperate with us? So that's one who learn something about this. And also, does this platform idea, which I talked about, will be discussed? What makes really sense for the people? So, kind of stock taking, and if you want, so I shouldn't use the word, I will not say marketing, but it's political communication that this is high on the agenda, this digital transformation of industry. I hope this answers. So it's reaching out, it's the first of its kind. Anybody can register now, it's of course late because it's tomorrow, but it's the first really large event on digitizing European industry.
Okay, thank you very much. I think we will leave further questions for the coffee break. And then I'm going to continue presenting more to CPS. So is it very much lower the voice if I talk into that microphone? Then I would use the other one, but I think if I'm going close to that, it's good enough. various workshops, mainly face-to-face, all those 500. And we had lots of interesting workshops here I'm going to tell you a little bit more about. And the outputs as such, I would say, are what will remain, and maybe I would advise you to have a look at if interested. So we did this impact and gap analysis, which is a report. We have, because it was not an easy made, custom-made tool for it, which I would later also recommend for further use by you, for example. We did a catalog of program achievements. We did case studies, which are targeted at SMEs. We have this technology application and strategy roadmap. We are having recommendations, which is a deliverable due tomorrow, so we will have it by tomorrow. Then we did a lot of community building workshops, and here we have quite interesting associated reports. You can find all of that quite easily on our website. Coming to the results and key messages we wanted to draw. Of course, we've seen great impact that has been achieved, but of course it's also hard to measure. So what we did is we extracted some impressive success stories. We did this catalog of program achievements for the ICT1 project, which we asked the coordinators directly. So this is kind of a booklet you can also spread. We have developed this customized tools and have this gap analysis. I'm just going to show you that tool. Of course, you can't really understand it like that, but maybe you can see that your project is listed here. So we have done that for 72 projects. So we had 54 in the beginning, and then the reviewers thought we could do another 18. So we had the Horizon 2020, ICT1, we had some from FP7, and we included some Artemis projects too. In this tool, there's a lot of information. So each and every project has been looked for, well, those closed for, is there patterns, applications, is there startups, is there like this, what we call impact, but we put much more information there about goals, aims, achievements. What else do they have? We have included loads of information there, and now the tool is there with a lot of information, and the question is if somebody of you wants to continue using this. So this is maybe something you can come up to me, but it's been done at Loughborough University, so Mikey Henshaw or Norrisington would be the right people to really target here if you want to kind of do something with the tool because the project is over. It will sleep in a way if we don't. With that tool and information, we also did the gap analysis, and this is much too complicated to understand, I see. We have 67 bubbles there, which are gaps. These gaps are on different interoperability levels, and then we have gray bubbles, which are the projects which target them. This is a great analysis. You can do per gap, per project, or whatever. So whoever is interested in knowing more about that should really come up to us. Then the catalog of program achievements. So this is something that you can use for yourself or spread or get informed about the ICT1 project. And through that activity we've seen, well, on the one side the gap analysis showed us that more federation of efforts is needed, so projects should be linked much better. The follow-up also should be better to really see what impact has been created. So if you really want to assess that, then the project should be in a way followed up much better. Custom then we're doing those 100 people events which are cluster projects and communities, but also disseminate to a broader community. So we think this is quite a good benefit, because what we saw is that in the road mapping workshops we put IoT people, factors of the future people, the IT community and everybody together, and sometimes they were not that aware that these roadmaps, these other roadmaps exist, and that they were mostly talking in the same direction. So it's good to bring these people even within the European Commercial Funded projects together. Another thing also is to really make a matchmaking between supply and demand. We did that for platforms, saying what is there on the supply side and what is really needed from the demand. Now coming to the road mapping, I'm not going to dive that deep into that, also for the time. We did a roadmap for the application domains, and here we had 5 domains: manufacturing, smart energy, smart transport, smart health, and smart city. I will not show you the individual needs of all those domains, but just capture what did they have in common. So what should maybe also technology teams have a look at. So it was always regulatory frameworks for the different domains. It was always like education or reskilling people. It was going for open solutions, standards, interoperability, to make it possible for SMEs also to enter that ecosystem. It was on enhancing ecosystem building as such. It was always addressing security and privacy issues. This could be on the technological side, but also on legal frameworks. And business models. Business models also go along with, of course, the culture of innovation or entrepreneurship. Then demonstrations would help a lot, and test beds to really test things, but they are up high already in the next program, and as said, success stories. This is for the application domains. Then this is kind of a repetition of what is there. The technological priority themes. Here it was also, maybe I have to mention, we did not kind of create a new roadmap, because just in the beginning of the project Anna said we have many roadmaps already, but try to find the concepts and update existing roadmaps. So we put many people in the room from the roadmaps running and kind of asked them, what are your priority themes? And then, so this is not totally new themes, this is more the themes that are really full consensus of the whole community. So the first 3 kind of go together. Integration, interoperability, reference architectures, platforms. This is something that always came up, and the EU has endorsed already. So this has become a real main topic of the initiative, digitizing the European industry initiative, and I think of the next work programs too. So much has been done there already, but this is still very high on the agenda. Regarding platforms, we can always discuss, of course, they should be open and modular and good access by everybody and so on. were not that happy when we asked people, and what is the really new things that are upcoming? That's not easy to get. So really, we even try to do visionary workshops and whatever. And then sometimes things come up, but it's, well, they are not involved with the community yet. But this is harder to get. So this is kind of the concept. And I think much of that is already involved with the community. Then the non-technological priority things are very important too. And here it was always education, training, skills coming up, and the business models, keeping the human in the loop, community building, collaboration, and as Lena said, also with national and regional collaboration, also for the funding, demonstrated strengths, regulation, legal issues, societal dialogue, ethics, of course, come into play, and the openness, open data, open innovation. And this, of course, led us to recommendations, which we can now guess which they are. It's kind of to follow really those research priorities and also non-technological ones, to fund platforms, which EC is doing already. That's the more digital or technological ones, of course, organizational ones, operational ones. So customer is good too, everything that people really exchange. Then facilitate funding for SMEs, but also startups, which is not that much in there. Digital innovation hubs are a very good means for such a thing. Support the overall ecosystem. Of course, defragmentation is always a topic in Europe. Fund demonstration test beds. I think this is in CPS also planned. Then have those CSAs, competence centers, digital innovation hubs, task forces, working groups, whatever, to bring people together and raise awareness. So, and invest in training and education, of course. So these are kind of the overall topics. But within our documents, you will have whole chapters about each of them. But this is, of course, going too much into detail. We do also have the recommendations for innovation strategies and business opportunities. And this is a shared presentation with Julia Delana from Atlas also wrote here. She will continue shortly on this.
Thank you very much, Neke. Good morning, everyone. My name is Nuria Delano. I work for the company Atlas, which is one of the partners of the consortium. My main objective today is to emphasize some of the aspects that have been mentioned by Neke just at the end of the presentation, and that have to do with not necessarily technical aspects, but that have a very important impact on the adoption of technologies. So during the last phase of Road to CPS, we have worked quite a lot on understanding what the innovation ecosystem should look like. Because the idea is not to promote a technology push approach, as we've been doing for many, many years, developing more technologies. I think that we have already quite a lot of technologies. I think it's more important for European countries to understand exactly what is needed to ensure that these technologies have a real impact on the market, that they are adopted, they are deployed, and they create benefits. So if we have a look at the position of Europe in the landscape of innovation, you will realize that we have improved in the last years quite a lot with respect to our main competitors like United States, South Korea, or Japan. And there is still a forecast of 2.5% growth in the coming years, but the reality is that we are still lagging behind many countries, including those ones that I have just mentioned. And I think it is not by chance that the European Commission created Horizon 2020 with a focus on innovation, instead of talking so much about research and development, which is still important. But as I said, innovation is the ability of creating impact out of the outcomes we get from the research projects. So what we really want to get is either economic impact, that we are able to create business out of that, or societal impact, any of them. But creating technologies per se is an asset, but it's not the most important thing in economics to create such impact. And one of the situations we live in the European Union is also that there is a great diversity of much time today. I will not go through all the details. You can have a look at that in the corresponding deliverables. But I want to point out specifically which are considered as challenges in order to make sure that this smart health scenario happens in reality. And when you come to these challenges, they are always of policy nature. So technologies are not so much a barrier. Most of the technologies already exist there. Of course, there is the need for interoperability and standardization. But then, when we come to the real problems that prevent us from having this impact on the market, we come to topics like address privacy issues, update and harmonize regulations, address data accessibility and security issues, foster innovation in the public sector. It's not just the availability of the technology, value in the future will not be in the car itself. The value will be in data, in the data you have access to. Because basically the fact that your car goes along means that you really need to have a clear understanding of what is the context, what is the position, which things are around, what is the infrastructure, what is happening at any moment in any of the systems of your car and outside your car. So basically the most valuable asset will be data, and that is why the competitors of our car manufacturers now will not be car manufacturers anymore, will be companies like Apple or Google that are already investing in autonomous driving. So this changes very much the business landscape, and when we talk about new technologies, we also have to think about these kind of things. Another important aspect is this digital single market, and I would like to insist on that again, because we've been talking about that for many, many years, but the reality is that this has not been realized. So at this very moment, the regulations are completely different, but also when there is a regulation that seems to be the same for everyone, it can be interpreted in different ways. So basically we have a mess. It's really impossible to have the same service running on top of different member states. And it is not only the degree of development of something. If we think about e-health, for example, in some countries they are not doing any work on electronic health records. So then how can we have interoperable services if they are based on the deployment of electronic health records? So this is a quite important thing. And then something that maybe is important to say is that in order to ensure that Europe is innovative, we really need to have a pro-innovation regulatory environment. And the reality is that now we say that Europe is quite open, but when we have companies like Uber that come to business in Europe, then maybe we are not so open. At least there are many countries that are against that because they feel that the competition is not fair. So we also have to think about all these kind of things because maybe we really want emerging business models, but these emerging business models are not in line with the current regulation. So let me go to the last slides. In terms of regulatory environment, I would like to mention, for example, some of the ongoing initiatives by the European Commission that are very important in this context of cyber-physical systems, like the free flow of data, or some regulations about data ownership or data liability. All these
and it's Michael Henshaw giving you that presentation. You can choose between this microphone. Okay.
Well, good morning, everyone. My name is Mike Henshaw. I'm a Professor of Systems Engineering at Loughborough University, and I led the TAM4CPS project. We're already about a quarter of an hour behind time, so I'll try to make up some time if I can, but I'll try not to go too fast on it. So, one way to perhaps get through the key points quickly is to put the key messages right at the beginning. So that's what I've done. So we have a number of events, and one of the things that we can say for sure is that researchers from both European Union and from the US have identified a number of areas for potential collaboration in modelling and simulation for cyber-physical systems, where they bring complementary skills. Now that's actually quite important, because if you're all doing the same thing, probably you don't want to collaborate. If there are benefits for both sides, that's important, and I'll come back to that very presently. It's been mentioned already in previous presentation, and also in Werner's presentation, that one of the key requirements for researchers is access to test beds, to test CPS, and also to test models of CPS as well. So if there's one key element, and I've got more details further down, test beds is very important. And the group to whom it is probably most important is SMEs. So a lot of big companies, they do have their own test beds and good access. Smaller companies don't have the same access to test beds in which to develop the innovation opportunities that Muriel just referred to. What's the biggest problem? The biggest problem for CPS and for models of CPS is verification. And all the things that I'll talk about, verification is kind of underpinning as a problem with those, and something that needs to be researched and dealt with. And the last point is perhaps a slightly odd one, but if we go back and look at previous projects that have looked at collaboration between the US and the European Union, and other projects, there was another one running at the same time as us, which was CPS Summit. Pretty well, the recommendations, the conclusions are similar from all of them. So in a sense, that kind of validates the fact that there's benefits to be had, but mostly they all identify some of the structural barriers to collaboration that need to be done. So let me just say a little bit about the project itself. There were three partners: Loughborough, Steinbase Europa, Zentrum, and Newcastle University. And just to introduce a couple of people here. So Sabina Zimmerman, right at the front here, was a key member of the team, and Sophia Pilfold, right at the back, is another member of the team who's done a lot of work on the deliverables that we have here now. It wasn't a requirement to have a double-barreled name to be on the project, but it seems to have helped. We were also very pleased to work with 5 US universities, and they were very generous in hosting workshops and actually contributing quite a lot in financial terms as well to the project. As George Mason, Georgia Institute of Technology, Purdue, University of Texas, and Stevens Institute. And we held workshops about different themes at those locations. And they also did a lot of the work in getting participants to come along to the workshops. So the motivation is that, if you like, the assumption this is based on is that there could be mutual benefit for US and Europe in collaborating in the area of cyber-physical systems, but in particular in the area of modelling and simulation. And that's quite an important point to keep in mind, is that the agenda that I shall present is not about cyber-physical system general, this is very specific about modelling and simulation for psychophysical systems. And our objective was to create an agenda for collaboration and to provide some other enablers that would assist that. So although there are quite a few deliverables, I would identify 3 key deliverables. The first one is the strategic agenda itself, which is available from our website as an e-book. There's a picture of it up in the corner there. To support that, we have 2 things. One is a state-of-the-art evaluation. Now, I'd like to just put a little caveat here. This is not a state-of-the-art about everything to do with modelling and simulation for CPS. It's a state-of-the-art relevant to the strategic agenda. And one of the things to bear in mind is with the strategic agenda, it's not about all the things that one should do in order to do modelling and simulation well. It's about the areas which are of mutual interest for researchers in the US and EU. So there may be some things you say, well, there's a gap there, that research element hasn't been identified. I think that's important. That may be true. But actually, it may be an area where either we couldn't identify that there was complementary work which would be worthwhile collaborating on, or in some cases it may be work where actually it's not advantageous to collaborate, it's better to do it yourself. And the other key deliverable is a set of test cases. Because our objective is to try to encourage collaboration, a very good way to start collaboration, particularly in the area of modelling and simulations, is to be able to compare the methods that you're using. One of the shortages that we would observe is in good data sets for people to make comparisons with. There's lots of data around, but open data that is accessible to researchers from wherever is not so accessible. So we've identified 4 test cases, a couple in automotive, 1 in health, and 1 in emergency response, where there are substantial databases that can be accessed, which could form the basis for initiating a collaboration. The approach we took was to hold what we call twin workshops, so workshops in Europe and workshops in the US. And we had 5 themes. These were based on themes from the 2013 Artemis report. In truth, I think what we found was that there was a lot of overlap between the themes, and the themes for research that have emerged do not precisely map to these particular themes. Quite a few items came up in several of the workshops, even though the researchers doing modelling and simulation may have been looking at different problems or different modelling approaches. We also conducted a number of interviews. These were primarily to look at the collaboration mechanisms. So what are the good mechanisms, good structures that can be used to foster collaboration between Europe and the US? Just a note on the type of models that would be within scope. So this diagram, it kind of comes from a different purpose, which was to sort of identify where CPS, Internet of Things and System of Systems fit. But I think it's quite helpful because one could have a cyber-physical system that isn't networked. But models of that are still important. And some of the researchers are working on models like that. So it could be perhaps very isolated machines with high levels of software embedded within them. If I jump to this side, the Internet of Things, these are cyber-physical systems which are networked through the Internet. And so they are system of systems. And again, there's lots of models that one could look at, and a high degree of complexity there because of networking. But there's also an interesting area here, depending on your application, which is where the networking is not just, it's either not through the Internet or it's in additional ways through the internet. So things like electromagnetic interference and that sort of thing might come into that category. Again, these could be very significant aspects to capturing models, but arguably could be the areas of interaction between different CPSs that are least well modelled. In terms of the models, I'm aware that you won't be able to read the part at the bottom here, but just to say that one could put different words here, but broadly, a lot of the experimental models are the sort of numerical models, perhaps some of the architecting models and that sort of thing, where technologists are mostly interested. But we also included within scope what we term descriptive models. And actually, in Werner's and in Micah's presentation, they touched on the aspects of the integration of CPS within the human environment. And some of the models that one needs there are the kind of societal models that help you understand the drivers and barriers to those interactions. So those were also within scope for our project. And lastly, just to say a little bit about complexity, this kind of mirrors the previous diagram, one just before that. So there's the individual systems, but then increasing amounts of networking as one rises up there. And the example we used in transport is from a single vehicle with driver assistance to convoys, then to interactions between vehicles, and then finally interactions not only between vehicles but between lots of infrastructure and other things. And the level of complexity there increases very significantly. And the important element there is that the models that work down here are not suitable for the bit up there. And so different modelling approaches are needed. And the levels of uncertainty within those models is very significant, particularly as you get up here. And so this is where research and understanding and accepting uncertainty and dealing with it becomes important. So we came to the conclusion there were 7 main themes for collaboration. And the first one, now these 7 aren't necessarily in a priority order, but I would argue that probably in terms of the one that came up most frequently, test beds was definitely the theme. Sorry, I've moved on. Too many buttons on here. So, test beds to... I think we're going to stop using this. I'm dangerous with it. I'll put it down. Test beds to verify models, but also to verify CPS. And in particular, we've included in the report some of the examples. So examples like M-City in Michigan, a huge facility for testing autonomous vehicles, sponsored by a lot of US industry, US universities and US government. Those are, and there are some big test beds in Europe as well, which are also touched on in our report. These are very important, but they're not open to everyone. And so, some of the things that one could look at is, first of all, use of resources. Maybe there are areas where jointly sponsored test beds between Europe and the US would be beneficial. But perhaps even more particularly and more achievable in the short term is exploiting the existing test beds by trying to find mechanisms through which they can be more open, and in particular more open to smaller organisations. And in the agenda we do list a lot of test beds that we've identified as being out there, and made some comments about their availability and how one might use them. Another thing, now this is interesting because although we had our kind of workshop themes went right from the inclusion of humans at one end to very, very almost purely technology aspects about CPS control. The inclusion of human factors in models came up in every single workshop, and it came up as a priority. And I think this is because many of the really big problems with CPS that need to be solved are those that involve the interaction with human workers. And again, you saw that in some of the presentations we just had. An area of particular importance is ways to identify and enable situational awareness of humans and CPS systems. And what I mean by that is human beings understanding the CPS systems that they are interacting with. And in particular, not what the CPS system is doing now, but what it's about to do. That's a major issue that's been identified for years with autopilot, for instance. And the other is the model that the CPS system has of its environment and how it understands, that's a bad word to use, but I think you know what I mean, how it understands its interaction with the human beings that are there. 3 and 4, first of all, an open framework for model interoperability. So this is pointing very much towards co-simulation and being able to rapidly bring models together to run co-simulation and work on particular problems. And theme 4 was one that really surprised me, actually, was to incorporate security architecture features into models. Now, security architecture, one would have thought, was probably too sensitive to work on. But actually, what came out from our workshops are there are some fairly fundamental aspects about this. In particular, what good metrics associated with the architectures that one might use to determine whether an architecture is good or not very good. A focus perhaps particularly on aspects associated with privacy and how one can model that. These came out as areas which would be open to collaboration. And this is a big one. So verification is an issue here. Now, there's the thing that came out was combining formal verification, simulation, and technology. So essentially, with highly complex systems, formal methods are just, well, almost certainly would just be too expensive to use. You just couldn't cover sufficient cases to do things. And so some aspects are maybe looking at the use of simulation technology as a way to enhance that. Now, there are a couple of things. So I'm really talking here about then leading on to things like qualification and certification of systems. And there's actually a big paradigm shift needed here, because this suggests that we need to think differently about the way that we certify systems. There are some recent authors, like 2016 authors, who would actually argue that formal methods are simply insufficient for verification, and actually we need to look at completely different ways of doing this as well. I think this is a research topic. I wouldn't express an opinion about it. This one is quite linked to the previous one. So this is about an evolutionary approach to testing and evaluation. In network CPS, the systems change very rapidly, and so formal ways of carrying out verification and testing, which are largely based on static approaches, may not be applicable. There are two challenges here. The first one is developing the necessary analytics, essentially for streaming data, to be able to update models and verify them rapidly. But the other one is actually, if you like, agreeing with regulatory authorities the acceptability of data-driven models for assurance. Interestingly, some recent work in the area of aerospace has shown some very promising results against the question, the first of those two challenges. But actually, it's still carried out only at test bases, and moving towards formal acceptance is still quite some way off. Although there is some effort to start looking at exactly how this would change the regulations surrounding airworthiness. And the last challenge, which we've seen already on some of the slides, is that of big data analytics. Essentially to enable better real-time control of systems, that's maybe one of the main aspects that this would would be applicable. But I think on the diagram on the right-hand side, there are a lot of challenges here, and I think you're probably aware of most of them. But in particular, I would say the variety of data, how you combine very different data types in a sufficiently well verified way is a major challenge and an area of important research. I think the other aspect is the development of fast that would enable real-time control. And lastly, it's not on my slide, but it's worthwhile mentioning there's a huge dependence on effective communication systems if one wants to use big data to drive real-time control. There are a number of collaboration mechanisms, and this is perhaps an appropriate time to perhaps address the question that's in quite a lot of your minds. So when we started the project, we were living in what we consider to be a relatively stable environment. There's been a very significant change with the new US administration, and it's very unclear what their relationship with Europe is likely to be. I think if one believes the newspapers, there could be a significant change in the European political landscape over the next year or two as well. And so, in terms of collaboration between Europe and the US, I think it's realistic to say there's going to be quite a bit of wait and see for things that happen at the political level. However, researchers have always been good at collaborating, and academic researchers especially good at collaborating. All academics live within an international environment, and I expect the academics who are here today, like me, you do quite a lot of your work with people in other countries. So I've highlighted, on this slide, there's a lot of different mechanisms there, some of which would require a lot of political energy, and some of which would require very little. The one that I've highlighted is probably the one that requires the least political effort. But in terms of enhancing collaboration, in many ways it's the most effective, which is really good support for mobility researchers. Because at the end of the day, collaboration happens between individuals and between individual groups. So even if you have a big relationship between country to country or something like that, the value comes out of the work of individuals who collaborate well. And so if I could identify something to be done in the short term, in these times of uncertainty, number 6 would probably be that one. So, very, very quickly, recommendations. I think maybe what I'll do is, these are all available to read. I'll fly through very quickly. Biggest one, test beds. We desperately need test beds available across the whole community, and looking at the different ways that that could be enabled would be very important. The next one actually, which is really very directly to the European Union, and I appreciate this European Commission is a bit tricky to in the current climate, but quite a lot of the dialogue has happened with the National Science Foundation of America, NSF. Our observation would be that actually NSF works at a very foundational level in terms of science, whereas a lot of the work that's sponsored by the European Commission through things like Horizon 2020 is much more at the applied level. And maybe looking at some of the other funding agencies, for instance the national labs in the US, there might be better alignment between the research interests. I think the one I'd point to pick out here is number 5. And this is where there could be some those of you like me who are involved in standards bodies, I don't know if you have the same observation, but some of the developing economies who have previously not taken that much interest in standards, apart from turning up, have started to become very aggressive about establishing standards. And so if Europe and the US want to maintain the initiative in areas like psychological systems, standards work is going to be very, very important if we don't want to be working according to the standards from other developing economies. Research and mobility I've mentioned. So I've identified the themes. Essentially, those are the themes that we would recommend looking at areas which could be developed for collaboration through European sponsorship, hopefully with sponsorship from the US as well. Critical deliverables, I've mentioned the strategic agenda, the state-of-the-art and the test cases. We have one more deliverable which we have to complete tomorrow, but you have a chance to influence it. So we've had an online survey that's been running for a few weeks, and we've got some responses from that. But, and some of you may already have filled it in, so don't fill it in. But if you haven't completed the online survey, then we have some paper copies here, which you could do just while you're drinking a coffee or something else. And let Sophia, who's at the back, have the copies back. We've just got time to add them in. So I return to my key messages there, and that's essentially my conclusion.
Thank you very much, Mike. So, any questions, Charles?
So Charles Robinson Gonzalez. You mentioned that we are working in international situation or epidemics, so maybe this isn't the case, but were there any particular surprises from the work of the Americans and the Europeans, differences that you discovered that surprised you?
I suppose I would say that the surprise was that there weren't many surprises. Very, very similar problems. It was also quite difficult to distinguish in most areas whether one side was ahead or the other. The area where the Americans are probably mostly ahead is in the areas of security. Although one might challenge that with some of the recent high-profile cases. But I think in terms of security research, there's perhaps a lot more investment in the US. But broadly, the topics that emerged, they were of genuine interest. Actually, one of the things I haven't mentioned is, in our report, we came up with a number of dream projects. So there's about 10 or 11 what we call dream projects. And essentially what we did there, we said, okay, if you wanted to do a project in this area, what would be your dream project to do with Europe? Or what would be your dream project to do with the US? And we kind of exchanged those. And so the 10 that we came up with were ones where we could genuinely identify researchers who would say, yes, that's what we would like to do with Europe, or that's what we would like to do with the US. But there weren't any big surprises.
Okay, any other questions? You know coffee is waiting. So thank you very much, Michael. So coffee is waiting in this room. We just brought it here because we wouldn't let you go into another room. You would never come back. I think we will start off at 20 past. You can still be chewing if you wish, but I think, yes, 20 past.
SCORPIUS is actually aiming to investigate how CPS can really benefit the business and the manufacturing industries. But as a second topic, it's really aiming to identify also a common framework where the stakeholders can really relate each other. CPS are a pretty new concept, especially manufacturing, and especially, as been mentioned earlier by some other speakers, in the small medium enterprise, to talk about CPS is not something to give for granted. Many small medium enterprise are really outside the technology, outside the concept, outside the way they can really undertake any type of implementation of that. SCORPIUS is a project that involves a pretty good blend of competences in the partnership. We have industrial partners, we have Siemens and Bosch, we have academic partners, Milano and SUZI, and research institution and a small medium enterprise, which is SUZI and Formex. That is just the workflow of the project, but it's not my intention to go in that. What I would like to really provide you with 3 quick snapshots on the point that we perceive as really valuable that we find during our activities. Our activities started from a very clear point that was not to start the technology, that has already been said by other speakers today, but start from the need of the industry. Whatever are the expectations, the issues, and the attitude that the industry has regarding this new smart technology. And in doing that, the first activity has been together, find the stakeholder in a number of interviews, more than 120 interview and contact, to really understand where the CPS could really bring a benefit and what are the associated obstacles. The result has been the generation of structures that is being summarized in 6 clusters, where we identified in the manufacturing industry what are the potential area of real benefit, of real breakthrough. This area you can see here, they are very quickly. The first one is related with the perception that the CPS can really change the business model of the manufacturing industry, or CPS can support a new business model in the manufacturing industry. The second one is acknowledge that products are no longer passive entities that is really produced and distributed, but an active component of the value chain. And so based on that, they completely change the way they need to be dealt with. The third one is acknowledge that the process and the value chain is spreading well beyond the boundary of the company. And so we have a manufacturing process that is extending for all along the supply chain, and not in just in monodirectional fashion, but in circular fashion, because the information coming in the following phases are retrofitted to the beginning, and so this is important to consider. Related with the production process, there is a need for the process to be flexible, reconfigurable, totally suited to the mass customization of the products, and of course need to be efficient. Fourth and the fifth, and the last one, another point that is been stressed many times this morning, the fact that the human factor is a key element. CPS are not there to replace people. CPS and smart technology are there to support the people in the different flavors you can imagine. It can be the workers, the user, the whatever way the human can interact with the production process and the utilization of the product. And all that has been clustered and ranked, associated with the benefit, but also with the obstacles. Because behind each of these potentiality, we have collected also what are the possible obstacles and hurdles can can be perceived in terms of actual adoption of this technology. And that has been our starting point. The second snapshot that I want to provide you is the vision that we derivate from it. The vision that we derivate was basically taking into account three aspects. The first aspect is that the classical manufacturing production process is there. We cannot expect to start from greenfield, and so there is a legacy of application processes and also attitude that we need to consider, and in doing that we have to adapt them to the new smart technology. And you can recognize in that in what we identify as the redefined automation for single pyramid. A pyramid where the level of the pyramid are no longer in a hierarchical way, but are made much more visible and transparent via the adoption of CPS, the technology, and IoT and whatever you want. Second consideration that we encapsulate in the vision is the fact that there is two main flows. One is related with the products, where the product is an entity that need to be followed and monitored and tracked all along the life cycle, from the very beginning, for the design till the end of life. And the same, this is a pretty brand new concept, is the case for the production asset. It is the factory, the process itself, is something that is deemed to be considered in terms of product life cycle. In doing that, so we can see the vision with some sections that demonstrate that both for the products where we have starting from the design till the end of life, we have a complete integration of the different phases, starting from the creation of the so-called digital twin of the products that is suitable to collect and to keep track of any significant information related for every single product that is designed for every single customer. And it is basically the need, the state-based mass customization approach that is being required. And second point, the information need to be provided in a closed-ring approach. So the information that are collected all along the life cycle need to be retrofitted in order to influence the process from the very beginning. And so that is key to be considered. The same, and this is the other section, the section of the production asset, where the production asset itself need to be designed in terms of total flexibility and adaptation to the need of the products that we need. All of them need to be sustained by standard levels, standard models. We call it RAMI, we can call it ISC 62264, whatever standard we want, because interoperability is a key in all the implementation that we are going to take. So there are basically this vision that has been defined in terms of general frame for the generation of the real program. This is what we call the navigation map of our roadmap, where we encompass a number of concepts that we figure out from the activity that we did in the last 2 weeks. We can recognize basically three main sections in our roadmap. First section that we call context factors, where we identify, beside the technical and technology implication, what are the actual elements that can influence and create some type of facilitation of obstacles to adoption of the CPS in manufacturing. I will enter in more detail in that in just a few minutes. The other set is related with the technology enablers. SCORPIUS was not intended to enter in depth in analyzing the specific technology aspects of the underlying technology, but is more interesting to investigate what we call the smart manufacturing technology, that are the applications that are really mapped on the production processes. Nevertheless, we have to be aware that the technology enablers are needed and need some requirement. These two parts, the context factor and the technology enabler, that are not, strictly speaking, part of the SCORPIUS roadmap, actually was addressed by the generation of recommendations. In fact, the SCORPIUS roadmap contains two sets of recommendations, one related with what we call the context factor, the second regarding the technology enablers. Let's just give you more insight on the context factors as we discovered. And it was really interesting listening for the true voice of the stakeholders to really understand what are the real concerns of the people that need to take decisions and to invest money in this type of application. And we found 5, actually 4 plus 1 key context factors. The first is related with aspect related with the cultural acceptance, educational and skills and knowledge related with CPS. Everybody in some community now is talking about CPS as smart technology. That is not said in the broad industrial manufacturing market. As I said, in small medium enterprise, this type of concepts are not given for granted. So we need a strong activity in terms of awareness and in terms of creation of skills. For instance, for my institution, that is a university, the creation of suitable skill is one of the key commitments that we put in the next year's plans. Another aspect is also perception. As every time there is something that is not well understood and well defined, there is a set of possible fears or concern that need to be clearly addressed in order to prevent any type of reactions. Second point is a clear business benefit cost model. So the definition of a clear way to measure the cost and the benefits associated with that. People in the IT, I think it's pretty used to this type of problem. I think that most of us has got the opportunity to see the different waves in some ICT fashions in the past, where some application was adapted just because it was cool, or it was something that everybody is going to do. Well, that is no longer the case. Now industry is asking for a clear way to measure the advantages and the return on the investment, especially for technology that are deeply impacting the business performance. Third point, laws and regulations. The new technology open a set of issues related with social, political, normative aspects. For instance, we can have some aspect related, as already mentioned, to the security, related with the liability, related with the actual ownership of the intellectual capital, and so this needed to be addressed. Fifth, the availability of the technology and the possibility to have this technology fruitful and can be utilized under certain conditions. We have not to be to hide ourselves that most of the technology that we utilize are not originally from Europe, coming from US. When you mentioned, we have some major players that actually control and develop this technology. The possibility to have a clear perspective on the evolution and the ownership of this technology is key to enable possible investment on that. And last point, it is somehow in between the technology and the context factor in the standardization and certification and interoperability. Basically, this is a requirement that is coming in order to ensure interoperability of the system, but very simply in order to have an investment that can be conserved in the future. And so there are the 6 factors that we need to consider. That led to a set of recommendations that you can read here that basically capture that. There are the 3 major recommendations that are related with education, with liability, and with standardizations. The same approach, we also issue some technological recommendations. They are, if you want, maybe more, I don't say trivial, but probably it can be expected. Of course, this type of smart technology required availability of a platform with certain characteristics. So to have devices that are self-powered, with a long life, with a system with capacity to elaborate a huge amount of data in a seamless fashion on a semantic base, with the capability to really transform data into useful information. Werner this morning mentioned about the revamping of artificial intelligence. Definitely everything related with self-learning, self-configurability and so on is something that really is fostering this concept. The concept of to create smart systems that are able on an evolutionary basis to transform their behavior and to evolve towards an awareness concept. And last, again, standards, here more under the technology aspect. And then we have in our roadmap, by the way, of course, is totally available, is downloadable, and there is some copies on the desk and the entrance. We have the 14 research priorities that we propose to the attention of the research agenda in Europe. These 14 areas that today probably are a bit difficult to go in detail considering the time we have, cover many aspects of manufacturing industry and are aiming to cover different parts of the value chain. So instead of entering in the detail of each of these research priority, I prefer that you provide this chart that is aiming to demonstrate how each of the 14 research priorities that SCORPIUS identified are actually impacting on the different context factors. So in order to demonstrate how this research priority are really impacting a broad set of aspects that we need to be considered. We have, for instance, all areas that is related with the development of a system that are able to capitalize and to utilize the knowledge of the production process in order to create a brand new paradigm for instance, we have the mass customization paradigm where we have what we call the manufacturing as a service. So the possibility to have the manufacturing that is per se something very physical, very tangible, managed at the same way we are used to manage now the services on the web. And of course, the concept of the human interaction. The human as a key element of the value chain. The human as key players as an element of flexibility. Let me add a point regarding this. That is that sometimes talking about CPS and advanced automation and the smart system, very often the human is seen as a replaceable entity. Instead, that is definitely a perspective that is completely wrong for two reasons. The first one is a big topic that is not social sustainable. We cannot go out there and pretend and expect that people accept that, okay, there's 20 million people with this technology. It's simply not acceptable. Second, because it's not true. Because at the end, the value of the manufacturing need to be found in the added value that the human different role can place on that. And so that's the role that is that's the sense of the recommendation that we generate. All that is contained in our white paper, that is the condensated deliverables that is made available on our website. And at the same way Michael said before, we are still on time to provide your feedback, so you can connect to our survey where we can provide us your feedback on our research priority and to add your comment on that, and we are more than glad to have your contribution on that.
Thanks a lot for this very interesting presentation. Any questions in the room? Okay.
Just for understanding, what is a cyber-native factory? What do you mean by circular economy?
Okay.
I haven't heard that before.
There is an easy question that is no, just I will come to just to give you a way to assess this document. Let's say that each of the 14 priorities that has been identified has a kind of single card on this, and so you can find all the explications. By the way, for each of the research priority, we also conduct a validation exercise that is aiming to position both the impact and the time frame for the adoption. So in order to provide some type of guidance for the research agendas. Coming to your question, cyber-native factories, basically in the spirit of the visions where not only the product life cycle, but also the asset as a life cycle, the idea is that we have to design the production systems in order to be suitable to evolve in the future, in order to be able to, in case of existing system, to encapsulate some existing system. But in terms of new system, to really evolve very easily and very quickly. Especially in certain industries, the cost of the assets, but more the time to market the production asset is not compatible with the market expectation. And by design suitable to the world is really multiple. And the second was?
Circular economy.
Circular economy. Okay, circular economy. That is a drawback of to put a title because we have to choose a few words and of course, okay, circular economy can be everything is talking about circular economy. Though the idea is twofold. The first one is now the manufacturing. We are talking about manufacturing here is to be considered all along the value chain, and so we need to go from well before the production phase and well beyond the shipping of the product. And the concept of circular is more focused in this case on the fact that the information that I collect all along the life cycle need to be available and influence all the phases in a circular fashion, so to say.
Okay, thank you very much. So we would move on to the high peak talk. So this is given by Marc de Raton, who's also the leader of the roadmap and the leader of the project, which is called La Rochelle, also in the room. Okay, so this high peak vision is updated 2 yearly, and this one is just renewed and out for a few weeks, right? So or is it out?
It's out since last week.
Okay, since last week. So we heard a presentation on that already. I think it fits very well in the community and it's very, very interesting. So enjoy.
So thank you very much. So I will. Okay. I will present the IPIC vision. So IPIC is now a CSA. It was previously a network of excellence, and we gather basically 450 researchers between academia and companies. And typically every 2 years we release a vision document. So as I just said, the last version was issued last week at the IT conference in Stockholm, where we have more than 500 attendees. And you could download it at this website. And we bring few of them, but I think that they are already gone. So it's quite a thick document, more than 100 pages. But you could only read the back page, which has a summary of the full page of recommendation. All the rest are the rationale. And typically, I will explain basically how we did it and some of the highlights. So the first point is that we try to get input from the evolution of the society, evolution of the market, the technology, and of course the position of Europe in this landscape. And from this we give a few recommendations. So that is this presentation. So what is the main highlight? So this will in a few minutes that I have try to compact off all of the highlights. So the first main point is what we call the cyber-physical entanglements. So basically, the closer link between the cyberspace, so computing system, and the real world. So cyber-physical systems are really at the core of this. So also with virtual reality, augmented reality, so all these are blending together. So you could see also games like Uncharted 4, which has really photorealistic things. This summer, everybody was playing with Pokemon Go in the streets. And so we see really this blurring between real and cyber world. And one other key aspect is that the computer didn't have the same form like this thing with a keyboard on a screen. So now your self-driving car is a computer on wheels. Your digital camera is a computer with a sound source. So typically this is the change, and we will see more and more that computer will disappear from this shape and blur into our environments. And this will also allow more close collaboration between human and computer. So it's why we call called the Centaur era. So Centaur, in fact, is a term that was coined by Garry Kasparov, because basically after being defeated by a computer in the game of chess, we could have thought that it will be disappointed, but on the contrary, he sees the power to work together with the computer. So now, in advanced chess, you have a team which is composed of a human and a computer that are working together against a similar team. On the level, on the quality of the team are better than the man alone. So that is basically what is called a centaur. We see also cobots. So robots now are not in jail like in the past because they could be harmful to humans, but they could work together with humans and are sensible to the human that are nearby. We have all in our smartphone this personal assistant like Siri, Cortana, Google Now, Alexa. So by the way, the Alexa from Amazon was sold out during the last Christmas because the demand was so huge in the US for this voice control system. So we see the next trend that was also highlighted this morning by Werner, is that now artificial intelligence is going everywhere. So it's really changing the man-machine interface with more natural interface. You are talking to the machine, they are interpreting your movement, your habits, and so not only keyboard on screen again. But the key point is that this new system, of course, should make intelligent decisions, it's what they are meant for, but also should give trustable decisions. And this is the key point here. And the key ingredient for trustability is, of course, security, but also keeping the privacy of the data. And now that these systems are interacting with the physical world, safety, meaning that the system should not physically harm people. And due to cost reason, this should coexist with the existing computing system. So mixed criticality is a key element also to merge this new requirement to the, let's say, all the computing systems. So privacy. So today, security privacy is a key point. And few people call IoT the Internet of Threats. So you have all seen that this Jeep Cherokee was hijacked by hackers, that a teenager were able to derail a tram, that a pacemaker could be hacked, that your smart fridge could be used for launching denial of service attacks. And unfortunately, we have very few companies really taking this seriously, and the number of startups on security are not so high as the startups on IoT. And really the key point is that the massive adoption of IoT and cyber physical system rely on confidence in terms of security and privacy. So that is a very important thing that need to be worked on. Trust is still for a critical application like self-driving car, like this robot surgeon. You really need, because your life is in the microprocessor, cannot say hands, of this machine. And well, the classical techniques are very difficult. Well, when you want to prove by design that the machine is running perfectly according to the requirement, is more and more difficult. So it's very difficult now with the current system to ensure the worst case execution time. So we need to find techniques to go beyond this predictability about design. And we should build systems that are trustable even if their components are untrusted. And of course these systems are not only single, but they are distributed, they are very complex. Some parts are black boxes, you don't really know what is inside, either for proprietary right or some other reason. So how we could trust this complex distributed system, this is also a very high challenge. One of the key also is how we compute, how we distribute computation. So now we have all these smart sensors that are integrated together and talking to each other, machine-to-machine communication, creating this Internet of Things. They all create And this is done generally on the cloud or on high-performance computing system. And what is today, what a lot of people are using this approach for creating new services. And now they could also control directly a physical system, so our cyber-physical entanglement. But what we say is that we need to change this model on really having the fact of abstracting, processing, and understanding all the data as early as possible. So bringing back the intelligence to the edge. So it's all the keywords that you have heard, like fog computing, edge computing, stream analytics, and so on. So the key point is transforming data, which is what all these systems are generating, into information, what is really the added value, as early as possible. And I will take a few examples. Wow. I think this one is quite clear. If you have a self-driving car, it should not rely on the cloud or on the network to take decisions. So safety will impose that basic autonomic function should rely locally and not on remote computing. So cloud and HPC cannot support many cyber-physical applications due to this safety requirement. But there are also other drives. So you know that the European population is becoming older and older. So keeping people at home is a key challenge. And for that, we need to detect if they fall. And basically, they fall in their bathroom or in their bedroom. And having a camera, sending all the data to the cloud is not the best information for best solution for privacy. So also here, you need to have local processing to analyze what is going on and only extract the relevant information, which is here only one bit that somebody is lying on the ground. Even for economical reason, if you have hundreds, thousands of cameras sending all the information to the cloud or all these sensors, so then you will need very large bandwidth. And even the 5G will not be enough to cover all this. So we need to analyze the raw data locally to really extract the relevant information and send it to the cloud. Next point that is also very important is that for quite a long time, Europe was saying, okay, we need to focus on software. And if you know Alan Kay, which is one of the key people in the object-oriented languages, say people who are really serious about software should also make their own hardware. So we need to retain European capacity to design hardware. And now we have a right opportunity because the PC area was basically the era of Intel. Mobile area was the era of ARM. For the CPS area, the match is still open. So here European company might have a chance to be the key player here. Of course, we have still the classical challenges of energy, and I see a few of them looking at their smartphone, wondering because we don't have a lot of power plug if they could stay for the full day without recharging. But okay, we should have very efficient computing system, and we need to find new paradigms. So we don't need always to have full precision, full floating point for some operation. Response time could be trade-off for energy and so on. So we need also to make approximate computing, or what we better say, adequate computing, to really use what is needed to make your operation. And we need a new programming concept. And again, here, if we have million, billion of IoT devices, their impact on the worldwide energy will be tremendous. So see, only today, the standby power of the devices, and if we multiply this by million and thousand, this will be a key challenge. So in the few minutes, I would like to highlight two other main challenges. The growing complexity of software and hardware. So if we get a data sheet of, full data sheet of SOC now, it's several thousand of pages. And you have very complex device made of processors, accelerator, DSP, GPU, crypto accelerator, FPGA, now deep learning accelerator, and in the future, quantum accelerators. So here, the complexity is very large, and there is a need to really have a holistic global approach for this system development. encompassing both hardware and software, library, component, system, really taking into the whole chain the constraint of performance, energy, power, and trustability and quality of service. And of course, managing complexity is why at the origin we design computers. And of course, interoperability and composability are key elements for managing this complexity. But in IPIC, we also think that we need to use the computer to help us to manage computer and this new cognitive system. So really use artificial intelligence techniques to generate new computing system. Well, it's already done in mechanical engineering. It's called generative design. I will give you an example here. So this strange shape is what the computer generates as the optimal solution to link the rear wheel of a bike to the mainframe. What the designer did, he didn't say, I want this and this and this. He only gave the goal and the constraints. And the system was exploring all the opportunities to find what is the most optimal solution for this problem. So again, here to manage complexity, we should tell the machine what are the constraints, the goal, and the machine are mature enough to try to explore all the solutions to find the best one and to help us to cope with the complexity problem. So now, I do not have to go into detail of all the constraints, also in the technology and so on, but we are at a crossing point because all the technology is going to an end. Let's say data scaling is stopping in a few years. We think also that the Moore's law will be stopping. We have the new application driven by the cyber-physical system, the interaction with the physical world, and so on. So that we need new ideas. So the US wants to reboot computing, but we don't think it's a good solution because if you reboot, you will end up with the same solution again. So the main idea is to reinvent computing by challenging the basic assumption. So the highlight as a conclusion of this IPIC is really the cyber-physical entanglement, the artificial intelligence, and human and machine collaboration. So we like to summarize this into one drawing that you will see in the document. And I would like to keep the 2 extra minutes to really show you a movie about this. And yeah, okay. So we could launch it, please. That is the summary of the vision.
It is time to reinvent computing. Information technology is now a part of our daily lives. It is a cornerstone of modern society and is evolving ever more rapidly. New challenges lie ahead. Computers are disappearing from view and are taking on new forms, such as cars, smart meters, wearables and devices, with a whole range of appearances and uses. They communicate with their users via artificial intelligence-based interfaces using sounds and images, just like humans interact with each other. The function of computers is shifting from carrying out computational tasks to truly collaborating with humans. Tomorrow's computer will augment reality to assist our lives and will also create a virtual world for us to explore. We call this the cyber-physical entanglement between the virtual and physical worlds. We need to trust both the machines and the information that they process and store, and therefore safety, security and privacy are vital. As the effects of climate change are increasingly seen, energy efficiency of computing systems remains a major challenge for the coming years. The environmental development and running costs of computing also needs to be monitored and controlled. With the arrival of many new systems and new system architectures, we must ensure composability. Innovative approaches will be required to ensure that the systems do what they are supposed to do. Artificial intelligence needs to be embedded close to the user to ensure safety, privacy and energy efficiency. We need to design techniques that go beyond predictability by design. which will allow us to use unreliable parts to build reliable systems. Holistic approaches and multidisciplinary techniques will be needed to meet the requirements of trustability, efficiency and cost. It is time to revisit the basic assumptions in order to open up new paths and approaches. It is time to reinvent computing.
Thank you very much for this. As said, I'm a great fan of this scientific vision. Anyway, I would recommend to anybody to read. So I would be happy for a hard copy. Okay, thank you. Yes, so any questions from the audience? So many. Who was first? Sorry. So Radi.
Hi, I'm Radi Grosso from Technical University of Vienna. I have the following question. So how are we building trust in systems that we don't understand? Like a deep neural network?
Well, that's a very good question, but one of the ideas here will be to basically make a supervisor. So something where you have rules and will ensure that the system that is observing will follow these rules. So it's again all the story from the Kubernetes time, where you have a supervisor that could control a free-running system. So that could be one of the approaches. But of course, if you have other idea, that will be good, because this is a key challenge and it's very hard, of course.
Thank you, Mikey. Thanks a lot, Mark, for giving this talk. Actually, it's not so much a question what's coming now, it's rather a comment. It's excellent. Thanks for showing to the audience, maybe it's better I stand up, for showing the audience what HighPeak does. HighPeak is, you said it, it's the computing project which I funded in Horizon 2020. And so this is good that you come to this group, to CPS, because there are not really borders. These are blurring, the activities have blurring frontiers, and there's overlap. So we in the Commission, we think that this exchange is very important, and it's one of the ideas of digitizing European industry, that you have the objective in mind. The objective is doing innovation in systems, in ICT systems, and then we bring all the players together. This is where we are good at. We are not doing the things ourselves. We bring the players together, who can do it, and you can do it. So also I want to say thank you for the SCORPIUS delegation, if I may say. If Panderan, the project officer, is also here. So it's excellent that you come and that you exchange views. Don't be scared, in the sense that if you come to an event from CPS, that there will be, that this might mean something for the future, how the budgets are distributed. You will see there will be enough budget that you can do your work in a good style, which is competitive. So seriously, don't be concerned about this. See the good things. The good things are that we want to bring you together. We all started talking about next part of the work program. It's still Horizon 2020, so what would come after 2018. And the thinking is a bit having under one heading, I think I just can say this, computing and cyber-physical systems together. Good. So see this as an opportunity also to get into this thinking. I think this will be very good and mutually fruitful. Good. That's actually my comment. You see that in the roadmap presentation that the projects are working on, they are complementary. Mark was talking about the vision, so pointing very much at the technologies, what is coming in the future, how could the future be look like, what we would need in terms of the technology. Then we had the business aspects from Nuria, from Road to CPS. We had the instantiation, if I may say, manufacturing, which was done by SCORPIUS, using again methods from cyber-physical systems, but applying them to the specific case of manufacturing. And whom did I forget? Of course not. It's very important that TAM4CPS also thinks how the European activities can be linked connected to activities otherwise in the world, in the United States, which is of course stays an important partner. We see how we continue working with them, but certainly it's very valuable what you did. So you see, like in music, there are themes which are the same, and then they are varied in the different pieces. So this is very good, and I want to say also to say, spell it out. The work which is done in the research projects is really helpful. And if we talk so much about innovation, it doesn't mean that we will scrap the research base. The research base will stay important. And what also stays important is the reflection, what the CSA are doing. So this will continue. But, as it was also said several times, this innovation aspect, that the research results are not in the drawer, literally speaking, they are not in the drawer, or on a shared drive, or on a website, and not much happens. This is also not variable. We use taxpayers' money, and it would be good to get the framework conditions right, and with your help, that these results are also used. This is what I wanted to say to close this old map presentation. Sorry for that, but I thought it would be a good thing.
Yeah, but we have one other question, which is going to be the last one.
So thank you, Werner. And I do also think that we are complementary, that we need to work together in order really to have an impact in the future. So together we will be stronger. I agree with you. So if you have a question, we could have it at the break, because I don't want to...
Yes.
Okay. One short question.
No, it was already.
Okay, here anyway.
Thank you very much. Okay, now we come to the 7 minutes challenge. So, you know it's going to be very hard, you know it's going to be very challenging. Maybe the ones staying under 7 minutes will get a present. I still have to think about what, but I know it's hard. But as you can see, time is very short, so I'm going to give the word to you already. So Matthias Alto from Uncovered.
Okay, thank you, Michael. So Matthias Alto, And as I said, in order to ensure that our predictions are certifiable, we use the technique reachability analysis, where we compute the set of all possible solutions of the system, starting from a set of initial states. So let's say this is a set of initial states. We screen lines of possible solutions, and then we also consider uncertain inputs because of sensor noise, and we also consider other certain system parameters. And we can prove that we cannot compute this exactly, so we compute over approximations, and if the over approximation doesn't hit any unsafe state, we can prove the correctness of the system. So there is no testing required, unless, of course, you want to test if your verification approach works correctly. And as I said, last time I talked about automated driving, we use exactly the same approach for automated driving. So this is a really horizontal approach, like I understand what you said, where we have many applications and we can always use the same methodology. So just a quick overview of how we get the model of the human. We did a lot of testing with motion capture systems and extract the data, and then find possible bounds of human movement capabilities. And then we use this. Online what we do is we track the human, we extract the relevant information, let's say that the joint angles of the human arm, and then we use these bounds of possible movements to compute a reachable set of the human physics, and then extract this to build the occupancy over time of the human. So here's an example where you see what we have tracked. This is a human arm, tracked in our lab. This is the computation. This is the space it can occupy after 16.7 milliseconds, after 33 milliseconds, and after 50 milliseconds. And you see the human arm can move quickly. However, our formal verification approach has a cycle time of 3.7 milliseconds. So we can compute much faster than the human is moving and verify the system while it's running. And I quickly show you a video of the test we ran in our lab. So here you see the sandwich assembly scenario. For example, and the robot should pour, let's say, liquids on sandwiches, and it's doing this in the way that is formally verified. So you could actually certify this approach. And we've already talked to the UK Health and Safety Agency, and they were very much interested in this. Especially because once you can certify the software, you can move the robot anywhere, and it's always automatically certified. Today, if you have like move the robot somewhere else, you need to re-certify the system, which is very costly, very time-consuming, and so your system, production system, is not very flexible. Okay, so to sum up. Oh, sorry, this is here. So to conclude, we can compute all possible solutions of the robot and also other systems like cars. The approach considers uncertain measurements of the robot itself and surrounding humans. Assuming that our mathematical model plus uncertainty, so we can capture uncertainties, captures all real behaviors, we can prove safety. And we also have a work package in our project for performance checking, where we check if our models conform with reality. And our strategy, control strategy for this example is complies with ISO 10281. And in the future, we'd like to integrate these results on the robot of body robots. This was the one in our lab, but we're also working on deploying this on this other robot. And we also want to do some user studies if this is acceptable for users. So thank you very much.
So our next speaker will be from SCORPIUS Munich, and he is the coordinator of the Set of Physical Systems Engineering Labs project, CPS events. Are there any questions? Or do you want to keep that for the break? Because we kind of
All right. Is it clear to hear me? Thank you so much. I realize that my wasn't quite. Okay, so this is Scientific Systems Engineering Labs. In contrast to the project that Matthias just presented,
this is an innovation action, so we dropped the research focus here. It's a network of design centers. There will be a second presentation just after me about another design center project. This is basically how we are set up. We have 9 partners in 6 European countries. We're setting up 6 so-called design centers all across Europe with a particular focus in various CPS engineering topics and application domains. This is a 3-year project, now entering into the 3rd year, and I'm going to summarize what we have done so far. So the main focus of this project is that we try to help European business to innovate with digital technologies and develop CPS-based products and services. And so we want to provide support for companies to advance the product portfolio, move into the CPS world in some way, and reach out for new application domains. On the other hand, we also want to stimulate the uptake of advanced ICT technologies, particularly among European SMEs. So we want to connect the businesses with research centers that are in the consortium of our project. So on the one hand side, to ensure that our research actually grounded in practical needs, and on the other hand, connect the businesses in order for them to get support, especially when it comes to prototyping initial ideas in their business context. The way we do it, our approach is what we call the industrial experiment. So we are reaching out to European businesses, asking for their ideas, what small, innovative application, product development would be. We partner the best ones with our design centers in the project, and we provide them support in training on particular technologies and skills, and also some technical support in collaborative development in those projects. In our consortium, we have research centers and universities, and also one industrial partner that provide a number of ICT technologies that are relevant to CPS developments, which we call platforms. And from those platforms, we set up those experiments and try to get as far as possible towards innovation. On the left-hand side of these slides, you can see some of the platforms in our network. The top one is provided especially by our center in Newcastle University, around multidisciplinary modeling and co-simulation tools for CPS design into CPS, which is also a project just presented this afternoon, and Crescendo and Ultra are technologies around that. And based on those platforms, we are running experiments concerned with multidisciplinary design of CPS for smart energy control, decentralized road traffic management, and also, which is in combination with another design center where I'm representing, a product and production co-simulation model for manufacturing, which leads to the next item here, which is about industrial automation. We provide development tools for digital control software, PLCs, and also a test bed, a small test bed that allows manufacturing to be run in an adaptive and flexible manner. And based on those elements, we are looking at providing support for augmenting legacy machine tools towards the IoT world in order to do smart manufacturing, also with the old stuff still in place in the factories. We're also looking at the process management for industrial and for energy management, and also on the big data type of real-time proactive manufacturing. The last bullet point here is about safety analysis and monitoring, simulation in safety-critical application domains like aircraft and robotic systems. We are running projects that enhance safety for robotic airfield management, for example, autonomous driving, and also for navigation of autonomous shuttles in a verified manner. 3 more platforms or centers that are providing those platforms, obviously in all the work is looking at the maritime domain, providing an integrated reference platform for the maritime domain. Typical experiments that we are running looks at how to optimize the time that ships are staying in port, how can we plan the route and the unloading and loading of ships, and also connect applications on a cloud basis. In Stockholm, we are looking at connecting The event will take place in Munich in May. If you're interested, grab the leaflets that are back there or ask some questions. Registration will start soon, and I will be happy to see some of you all your contact.
Thank you very much for that. Now you can please. Are there any questions on the CPS ebooks? No? Are there any remaining questions on the Uncover CPS project? Also no questions. Okay, go further. The next one is EuroCPS, which is also a cascading funding project similar to CPS, and Isabel will present this project to you. She's from CEA in France.
So EuroCPS is, has lots of similarities with CPS lab, and they were both selected and they have both been working since the last 2 years under the SmartCPS initiative launched by the European Commission already also 2 years ago. So EuroCPS is a holistic project which gathered several design standards in order to put synergies between innovative companies, innovative CPS platform and CPS company providers. So it was launched 2 years ago, and it's also like CPS Lab in these last years. It gathered 9 countries, 15 partners, and among these 15 partners we have technology providers. The budget is around 9 million euros and the funding corresponds to 8 million euros. Sorry. Most of the budget is dedicated to industry experiments and project with selected support, which corresponds to 76% of the EuroCPS funding. The first goal of the EuroCPS funding is to bring innovative CPS to business community sectors. And for that first goal, the networking partners are the key partners for that networking, but they're also trying to determine, estimate the need and define the applications which we are looking for. The second objective is to link the user suppliers across the value chain and regions, and here the competence partners are the key actors because they bring their competence better for coaching, to extend the know-how, and to work on and to assist the SMEs on the research aspect of the work. Platform providers are here to provide technological issues in it to reach the outcome, which is to get innovative CPS products and to sustain the demand for European manufacturing. All this work, I would say, all these objectives are supported, managed, and monitored because we cascade funding partners. In principle, we won't have, usually ideas are among SMEs, and the objective is to have as much as possible SMEs to be aware of the project through networking, through press release, through local actions by our networking partners. And then proposals to come up from that. We plan to at least receive around 80 proposals, and among these proposals we will need to select proposals that we are going to fund for the whole process. And if we are very successful, we would like at least to get 10 success stories to tell at the end of the project. To reach that and to put a storyboard, we have organized 2 open calls, like EuroCPS, every 6 months, and the last call was closed in January last year. The evaluated proposals are selected, and we have 3 criteria. One is excellence, second one is quality, and the third one is impact. And as a matter of fact, we are ranking the impact as higher rank as a criteria for selections. Most of the proposals they last between 6 and 18 months, and they all been targeted in terms of TRM is between 5 and 7. So we have 3 kinds. EuroCPS is supporting 3 kinds of industrial experiments, which, as you will see, is much more depending on the platform which are the platform partners which are involved in the project. So we have software-intensive project, more system integration project, and the third one is more based on use of innovative component projects. For the software and system integration projects, as you use, I would say, components on the shelf in a way, we are expecting prototype demonstrator by the end of the proposal within the EuroCPS frame. For the one using based on innovative component projects, just to have, as Amazon manager, we had three calls, and this is just to give you an overview of the results of the 3 calls. So we received finally 118 proposals, and 34 was selected as projects. It corresponds to 11 random countries, and among which 2 are not represented by the consortium. So, and even more were concerned by the proposal we received. So, I mean, our networking has been quite efficient anyway, and more than 75% of the industry experiments are cross borders, which means that the 3 partners, the platform, the competence, and the autonomy, are from different countries, are from 2 different countries. And I will say that last words, it's just to illustrate the applications domain we've covered with all our industry experiments. So it's here on the left-hand side. And well, as you can see, it covers most of the topic SMEs from smart mobility, smart factory, IT protocol, and smart agriculture. So it's last year of the project. First projects are ending, and I hope that next time I will have occasion to tell you lots of success stories with our project. Thank you.
Time for questions. Any questions? So don't be shy. We allocated time for questions. Anyone?
Thank you. Thanks a lot for this nice overview. I want to ask a bit about the role of large industry. You are not from large industry,
Yeah.
you just coordinating. But it looks like that the large industry, they provide in this project hardware platforms, isn't it?
Yeah.
Yeah. So, tricky question, I think it's easy to answer. But normally, if an industry offers a platform, it's up to them to do the marketing that is going to be used. SmartCPS, we help a bit.
Yeah.
We give money on it. How would you say if somebody asks me, yeah, why is this good? What would you answer? What is the added value?
I will say, first of all, I think it was very attractive to SMEs because large company, they don't have direct contact. Usually they don't have direct contact with SMEs. There's a kind of otherwise. So for the SMEs, it was easier, I think, for them to enter. And I think it's also for our technological platform providers, one in the group. I think it was also very interesting for them to work directly with them and to see more of their needs. And for some of them, I know that they have been, because they are proposing services, and then in way they have worked a lot on that, what they call that communication kit, the way to speak and the way to work with the SMEs. And and they were very, also because then they discovered the needs of the SMEs. And these people are not always aware directly of what they need behind. So I think it's one of the things we want to tackle quite a lot is what are the benefits from the SMEs, but also for our platform providers. And well, it was for them, in a way for them it was to discover this work and also to try to build relationships and to see in which field and how they might work further on to support all these SMEs which are everywhere and how to make it easier for them to work together. So I hope I answered the question. impacts. But well, I think that maybe what we have to think over is that even though we try to, we tackle nearly prototype demonstrators, time to market is still a bit further away from us. So, well, we have to keep the time, I think we have to work to keep the timeline consistent one with the other, because we can't expect from that to have direct impact. It may be impact in terms of pattern, it may be impact in terms of collaborations, but it may invest some road to go through before reaching what they would call maybe success stories or well, if we get a new intel or good or whatever from these SMEs.
Yeah, I think Isabel already mentioned the main items here. So when our two projects started, the main focus was on providing the technology competence. And we are competency centers as our design center networks for them. So the next step obviously is what Isabel also mentioned, is providing the innovation management support, getting access to the further financiation of really industrializing the prototypes, getting further support with business models and really marketing. And I think the EU, with the next call of those projects, already goes in the right direction with this enlargement of the projects from the competence centers towards the digital innovation hubs, which also encompass more of those digital services. However, on the other hand, that means that you need to extend the consortium of such projects, bringing in all those functions. In our project, we are basically research centers and universities providing the technology side, and of course, achieving this impact needs also competencies that Isabel mentioned, also on the business and marketing side, and access to finance. So this means, well, we have extremely successful mechanism of these open calls, putting some money on the table both for the competency center to provide the support and also for the SMEs to really pay their time and development effort that otherwise they cannot afford. However, we need to go beyond that in order to also finance the other functions that have been mentioned towards really the next step after the project.
Thanks a lot.
So our next speaker is Ruben House, and he's presenting some case speeches. He's the coordinator of this very project, and he's from Statesman.
Yes, thank you very much. So I'm talking about the project SmartCPS, which is a very small innovation action and more in the line of a support action. I will tell you, I will in fact spend most of my time telling you where the problem lies that we want to solve, in presenting you the what we call the probability specification, the need for supporting this specification, and then our solution, which is a database and a so-called communication problem. The main problem we are concerning ourselves with, and one of the main challenges when you want to develop highly complex, safety-relevant modern CPS is the integration of a large number of heterogeneous development tools into system engineering environments. So the situation as we see it today is that if you want to build a plane, if you want to build a car, and especially the electronics and the software in these cyber-physical systems, you have a lot of industrial processes, and these processes are supported by a lot of software tools. And if I say a lot of software tools, it's really a huge number. If you want to build a plane today, you need literally 1,000 software tools to develop it, to have your links to marketing, to management, and so on. And these tools have been developed separately, and they have never been developed to work with each other and to exchange data. So what you end up with is a development process with a highly fragmented IT, which involves high maintenance costs, where you have high manual efforts to handle this data, and where this really fragmented software landscape costs you, or has a large impact on quality and also on safety of the design. And one of the solutions that we pursued within the Artemisia Association and in the projects that were launched mostly within the Artemis joint undertaking is to develop an open standard for development tool interoperability. This standard is called iOS, rather perhaps not the best name, but it's called that. It's the interoperability specification, and what you do is you build but it will in fact also enable new processes. You can now do global searches for data and all the software tools that you have. You can do trade-off analysis, which was very demanding before. You can verify your design to the requirements, which was also very, very difficult to do with all these. So this specification has been developed in a lot of Artemis projects, and in fact these projects were incubated by the Artemisia community, and in fact iOS is really a success story for Artemisia. If you think about it, we have this series of large projects which fits the Artemisia strategy of thinking big for projects, which move along a predefined research agenda toward a common goal, which is standardization. So this series of projects really is a huge success story of Artemisia. If you go into the technical details of the iOS, you see that iOS is not a single standard, but it's a set of specifications. I will not go into too much details there, but the idea pursued in this project was wherever you can find a standard that is already suitable and already used in the development process, integrate it, define extensions so that we could support data exchange to the best that's needed for the engineers, and also define bridges between these standards. So iOS really builds upon a lot of existing standards, and thus in turn it is not easy to map this specification to a single standardization model, because you have all these existing standards that merge into the iOS. On the other hand, we still expect a lot of projects to extend the specification, cover parts of the design process which are perhaps not so good covered by now. We will expect projects to build tools that adhere to these interoperability specification, and we also expect to drive formal standardization and connect to all the standardization bodies that are involved in the iOS specification. And this cannot easily be done because we have not a single standardization body where this standard resides. Yeah? We have specifications, we have implementations, and any other information which is scattered amongst various projects and existing standards. You cannot even, if you are not an expert, you cannot even easily answer the question, what is the current most recent version of a specific iOS part? How do these different parts fit together? Are there parallel developments? What maturity does a specific part have? And so on and so on. This has worked reasonably well in the past because the number of projects that developed iOS was small. This is no longer the case, it does not work anymore. So what we're going to need is two assets. We need, first of all, a single place where all information about these iOS is collected and available to all stakeholders. Oh, 1 minute, that's good. This we call the iOS database, and we need a place where all the stakeholders can meet, where they can drive further standardization, where they can drive extensions of the project. So this platform where the stakeholders can meet would incubate new projects, would provide means for sustainable achievement of project results, would be in contact with the standardization bodies and enable formal standardization. It would be open to all stakeholders, it would be sustainable, it would not be a project but last longer, and it would be hosted within existing structures. And we call this structure the iOS Coordination Forum, or ICF for short. The CPCS project is about to set up this ICF and also the iOS database. And what we have done so far is we have a prototype of the database installed. It will be available to the public by end of February. We have a proposal for installing the ICF as a Artemisia working group. This has been presented to the Artemisia steering board, which there was very good feedback. So we expect this to be set up by May of this year. So for a summary, we have this interoperability specification that is a success story of Artemisia. We have on the other hand this iOS as a multi-standard that raises new challenges with regard to performance standardization, and coordination forums like ICF are a solution to overcome these challenges, and we will implement this coordination forum especially for the iOS. Thank you very much.
Questions? Also no questions. Are you sure?
So sometimes the sustainability of projects is a question. I see yours being already like taken up now and for sure in at least Artemisia, which makes it kind of more sustainable in a way, right?
Exactly. So the object of some results within the project, of course, also project results within the project, but especially to set up a sustainable structure. So this is like the coordination forum, and we will do that. It looks very promising that we will reach this goal, and we will in fact have some, I don't know whether this is the correct English word, but a floating transition from the work done in SCORPIUS to the work then done in this coordination forum. There will be special events while both are running, and then the ICF will take off.
I'm not sure if I correctly understood. You say that you're concluding discussions with standards bodies,
yes,
but you're going to conduct work outside of the standards bodies. Is there a reason why you wouldn't do this through the regular standards bodies like ISO or something like that?
Yeah, perhaps this was a misunderstanding. But see, what happens is that we, when we try to implement interoperability between tools in different or the same engineering step, we look which standards are available and incorporate them. And then, of course, we have contact with the standardization bodies, we have contact with these people who stand behind the standard and are pushing the standard, of course. But then what always happens is that we find out and that we have a project that says, okay, this is a good basis, but what is needed in advance? And this is, you could immediately put these back to the standard, but we prefer first to have these demonstrators within the project see, is this really what we wanted, this extension? Does it work at all? Is this a good way, or perhaps even the best way of doing that? And then with the results of the project, which are extensions to the existing standard, and probably relations to standards in neighboring process steps, go back to the standardization body and say, look here, it's proven in use, we have done it, it's ready to be put back in the standard. And then go, depending on the standardization body, through the steps of pushing formal standardization of this.
I want just comment on that. I'm working in several with our groups. ISO and IC standardization groups, but they have always very specific focus. For instance, in IC 1608, functional safety, there's a put up conditions and requirements for tools, but not for tool chains. Yeah? And we try now in edition 3 to start with bringing this idea that we need, of course, standards for tool chains as well, because if you rely on a tool chain, it's quite different than to rely on a tool. And we try that, but it takes some time. That's the problem. We have to test it before. The same is in some ISO standards and OASIS standards where we are.
Any more questions? Thank you again.
Our next presentation will be Item Things, presented by Oscar Suarez, Andalusia, and Spain.
actually part of one of the demonstrators in which we want to insert the device into a doll's head and try and recognize the girl's facial emotions. And this is another example which is basically showing video streaming with the device doesn't work. Anyway, here's the four-factor camera and it is battery operated. It is streaming video to the Android smartphone. We want to show the platform demonstrated in 4 different applications. First one is what we call big pole surveillance. The idea here is to attach, say you go on vacation for 1 week, you attach the device to the big hole on your door, and you configure it from your smartphone, and then assuming you have Wi-Fi at home, it will be able to send you alarms when someone's knocking on your door or simply on your door. Another one, it's a hands-free automatic museum on the guide. The visitor arrives at the museum, takes one of these devices, it will be in a headset configuration. It contains a camera and it will be constantly monitoring what you're looking at. If it recognizes a painting, it will provide audio feedback about the painting. You don't have to do anything, just look at the painting. That's the idea. This is the one I mentioned previously, the doll that can recognize the child's facial emotions. And the fourth one is a wearable light-blowing camera. Actually, that was the initial idea, but turns out that light-blowing cameras are not a commercial success. So we are mostly focusing this on simply a portable camera.
Questions on either things?
Thanks. This is inspiring. You said you produced a lot of software. There was a whole table. What's going to happen with this software? Can anybody else use it? Is it EOT, proprietary thing? What's your view on it? How simple is it to use it? You need to have a PhD in computer science to do something meaningful.
It will be open source. Most of it, practically, it will be open source. Program to use it. What I can say is that with this, we are actually bridging a gap between what we found at the beginning, which was something extremely difficult to use, and what we have produced.
Okay, very good. You have signs that anybody else who is not in EOT has used this software. You have indications. Can you give an example?
Well, for example, the main partner that we use is the one producing the main element, I should say, of this platform, which is right at the center. A very efficient processor for computation and other applications. They are themselves using our software with other clients.
Any more questions? Okay, you seem to be quite hungry then. So we're having lunch now on the first floor. You can use the elevator, it will bring you directly to the restaurant. And please be back here at 2 o'clock. We're starting again at 2 o'clock.
Okay, so I'm very pleased that we have. Okay, so I'm very pleased that we have as our industrial keynote Roland Rosen, who is principal key research scientist at Corporate Technology for Siemens, a company very much engaged and involved in cyber-physical systems. His own specialism or area of interest is modelling and simulation, which makes it very appropriate to some of the discussion that we've had already today. And he's the project manager for the Industry 4.0 at Siemens. Because we're a short time, I won't give any more introduction, but I'm sure you'll say some more. We'll hand over to you now to hear what you have to say.
Yeah, thank you for the kindly introduction, and welcome here from my side. Hopefully it works here with the microphone. Please give me a sign if I hold it in the wrong way. Yeah, as mentioned before, I'm coming from the corporate unit from Siemens, responsible for industrial research for all Siemens business units. From this viewpoint, my interest to transfer research results into Siemens business in the broad field of all applications, from our products, systems, and solutions. In today's presentation, my focus is more on the products, product development, and the production. And the key objective today for me and every time for a business company is to create benefits for the customers and thus value for the own company, for our company, and I guess is valid, this concept for all business and all companies. The general scenario and use case-based approach which I present here today, we have already also introduced to the German platform Industry 4.0. Because it's a brand name, I try to speak the German words Industry 4.0, but in most cases we come to the conclusion. And in general, I'm convinced, and in the morning I've heard it in a similar way also from other presenters, this approach to take a look to the customer benefits and to pull and to show which technology is needed is also valid on a European level. And I hope I don't bore you. Hopefully I can bring you a little bit over the sleepiness time after lunch. So I won't start with some Siemens financial or organizational slides. So I will start from some megatrends. And as you know, and if you only look to the industrial side, we have a lot of megatrends. The globalization, change, urbanization, the demographic change, and of course also the digitalization. And if you speak about digitalizations, and often, not only from our sides, a slide comes which shows which lot of huge data we have. And this leads me sometimes to the comment that to speak in the era of digitalization from megatrends, and we have here zettabytes, so we have to multiply the mega by peta. This means 10 to the power of 15, that becomes from mega to the zettabytes. However, as mentioned here in this slides, hopefully you can read it a little bit. We live here in a world of complex and interconnected systems. So we are at the core of cyber-physical systems, I guess, and of course some influence of Internet of Things and so on. And this allow me to focus here quite quickly to three aspects. Not surprising, I guess, for you. We, and of course at first as end customers, we have seen in the last years that the business models change dramatically. The way in which we listen to music or we buy some books has changed. here you can see some typical examples. And this point leads me immediately to the third aspect, that in the products also some digitalization is inside. So in my opinion, there are some cyber-physical system inside, or sometimes in the systems or a set of cyber-physical systems. And from this point, yes, of course, the products of tomorrow will be more modular, will connected, will run, and of course there are some brains inside. Later on I will repeat it and come to the digital twin idea, and of course it should be plug and operating. And if you take a look to the technology, and once again it's not surprising for you, the topics mentioned here are already mentioned in the morning, and I'm sure also in the afternoon in the other sessions we come more or less to the same technology which are needed further steps and further research work. And if we go here a little bit closer to the automation of the future, then of course you know the golden triangle of cost, quality and time. And with a look to the mass customization or the lot size 1, we need more flexibility. And this leads us to in our company that we define a new production environment, which you can see here with some typical requirements for dynamic networking, flexible production steps, and so on. And aspects of self-organization, once more typical for cyber-physical systems. And yes, we are already clustered this technology here in 4 core aspects in future. And if you look once again to product and production system, modular production units or production cells will be connected, will be managed more and more autonomously their work, and they collect and use some data which comes from the design phases, and of course also collected during operation or of course during production about the production system. And yeah, so from a research point, and I mentioned in the beginning that I come from an industrial research organization, so sometimes I also on the research side, as I see a lot of research questions and see the chance to contribute to research projects on national and European side, and yeah, I'm interested. And on the other side, from an industrial key point, I have to take the question into account, do we really see the right challenges? And to motivate this, and I guess it's not surprising that I came to the same answer as you, here a little bit a short time clip. We are starting in the mid of the 19th century. There are in many workshops, there was individualized products produced but with low quantity. And you know it all from the assembly sign production here from the Ford T model, and here, sorry for the German picture of the people, we are going more and more in mass customization. And of course, with the help and support of automation, it was possible. And maybe the older persons here in the room know it like me, that starting maybe in the 1980s, we have more and more product configurators. And this allows that you can configure some mass products in a more or less individualized way. So it leads to the issue that in the automotive industry, I know some numbers here from German companies, not more than 1.3 or 1.4 cars are really identical. And yeah, this trend is ongoing, and it's changing a little bit from configurations to really lot size 1, that you can, and once again, you know it all from the end customer industry. If you realize your electronic calendar with this picture pictures and something that you can define really your own products. So this trend will be continued, and we have the other three trends that of course we are globally acting, and this is not only valid for big companies like Siemens. I know it very well also from some small and medium companies that I produce, maybe in Germany, maybe worldwide, but they are not worldwide. And not surprising too, we have the other aspect and trend of regionalization. And during lunch I spoke with my neighbors at the table and speak about the Chinese market, and everyone knows that in Chinese, in the automotive industry, the most customers like long version cars. So it's a specific requirement. From my own company, I know that sometimes we have to change the product and how is the usability of the product for the Chinese market. And so we have on the one side the aspect of globalization, on the other side the regionalization. And of course the continued trend of personalization. This means that God says one. And of course, and it's I guess it's will ever time valid, the time cost and quality aspect is important, but the new one is the flexibility, and this leads me that later on I will show you an example on this topic. Once again, and this is a basic concept which I mentioned in the beginning, and we have introduced it also to the German platform industry. If you look at first to the customer benefits, define it. Yes, take a look to your own strengths, so it's really important, and then take a use case-based approach to elaborate which research do you need, which is the best way to realize some of your new ideas. And this leads me to the next point, which I like to explain here on one diagram. This diagram was elaborated by a German technical committee from the German Association for Measurement and Automation Technology, and it shows, if you see, sorry, was too fast. If you show here the different life cycle and how in a production context the systems and the life cycles are connected. So here we see the different life cycle phases. You can see the product life cycle management, how to realize the production system, and of course if you come to the operation, to the production itself, the supply chain management is important, and of course the service is another important topic. And coming from this picture, the next step here and used in the platform was to define some general scenarios which allow you to define some specific points which are important from a customer side. And in the German platform there was defined 9 different scenarios. It's clear for me that you cannot read. You don't take a picture, you can download it from the online library on the German platform, and there is some text document available also in English language, so you can download it. And as mentioned before, I will take a look to the adaptive factory scenario, and this means, which you can also read here, this application scenario focus on a production resource and describes how this can be designed with respect to adaptability and how this impacts to the supplier of the production equipment, how can it improve and change the way how the system integrator acts, and of course what is the advantage for the operator, and last but not least for the manager of the plant. And yes, the next step is that scenario is fine. On the other side, you need some concrete examples for validate some.
The Industry 4.0 demonstrator is digitalization brought to life. A manufacturing cell with its flexible transport system constructed in physical form. The modular processing stations are reflected at a digital level. This is how the virtual and real worlds merge into one.
Okay, the movie starts a little bit fast, but however, this example shows in a merge scenario of virtual and real world how the equipment can work together. And here in this scenario, and one of the examples which is shown on this demonstrator is if you are interested and there is another market demand for selling some bottles with a spray nozzle or without a spray nozzle, so you can exchange one of the production units by another, and immediately after changing this plug and operate functionality, the system works again. And coming back to the points which mentioned before in the scenario, what is the benefits for the different stakeholders. I guess it's clear for the operator, he can answer immediately on a changed demand. It's a benefit for the machine supplier, or for the machine supplier who can offer these capabilities that you bring with the machine, the plug and play capability, and of course that before he has some digital information about his machines, so the system integrator can plan with this functionality. Yeah, this brings me and us to the conclusion. 3 slides more. One last slide here from the German platform Industry 4.0. This approach was, or leads to the fact that beyond the platform with some working groups and so on, we have founded so-called Labs Network Industry 4.0. It's an association for a test bed and test center for different applications. One of this was the application which I shown before. And of course, not mentioned here in my presentation, but I guess not surprising to you, standards and to define some standards in an international context is another topic. So it leads to the foundation of the Standardization Council Industry 4.0. And of course, other topic which I like to mention is that of course there are some cooperations on the European level. Industrie du Futur is one example. Other examples go outside of the Europe to the IICs. There are some regular meetings and some joint working groups together with the platform. And of course, and I guess you know it, it's one of the topic also for the Japan and German-Chinese discussion topics. Second point is, and I'm really convinced, that we are changing from automated system to autonomous system. So for me, the next level of next generation of CPS will be autonomous systems, and not only understood in a way that autonomy means always that it's related only to motion. This is one topic, one really important topic if you look to the automotive industry or to the robotics. And please don't understand me in the wrong way. Autonomy is not all. I guess the products, and maybe some of the products will be part of a production system as a production equipment. So all products will be more or less a CPS, or they have some sets of CPS inside, and of course connected each with another. And important for me is that in this system also some data coming from the beginning of the design and engineering phase of this product, also coming of some partners which are contribute to the development of the system by delivering components. Some digital information is will connect different life cycles and will connect different value chains. Simple example is that the product and the output of one production system will be a part of another systems, and this is state that in all, more or less in all products are CPS are inside, so the digital twin will help us to bring some customer benefit here to the real world. And of course, I did not mention all topics which are relevant for research. I totally missed the aspect of safety and security. Of course, it's an important topic. It's my last message here. I didn't talk about the human. And of course, the human is really important, and I am absolutely convinced that the use of CPS, the use of the digital twin, the use of autonomous system will be support us, will be help us that we come to a next level of creativity. And this don't means that we are not the boss here in the scenario. The human will be keep the central planner. He will be the person who makes the final decisions. In some cases, of course, the CPS or some autonomous system will support us, but this will and should keep us as a decision maker on the top level and will support us in creativity and hopefully comes to the next level of benefits. Yeah, thank you, and if you have some questions.
Hi, very nice talk. So I was wondering, you guys have seen myself also developing all the infrastructure like IoT, sensors, actuators, fog, cloud, operating system that allows you to configure this. Yeah. Quite right. And maybe you can see that I come originally from modeling and simulation and not from the IoT side, but I guess it's valid. And for me, it's not surprising, but I guess we have to consider that for other people, sometimes it's not so easy to understand that we have a deep integration of different technologies, and we have some big terms, not only big data, data analytics, IoT, and so on. And my feeling is that many people don't understand what is our topic and what is our core message. On the one side, I guess it's clear we have a mix of different technology which is required to fulfill the demands. And on the other side, it's not so easy to understand what we are speaking. And it was during lunch one of the topic, we have some negative communication if we speak about digitalization. And yes, maybe sometimes some people are afraid about digitalization because they don't know what's coming in the next. And I give sometimes in the years some speech to the worker council in our own company, and the same question arises. Same question, I told more about technology,
Okay. Just one more, I think, then we'll get to move on.
So, sorry for the long.
No, that was fine.
To another question.
Sinclair from London University. The SmartCPS project has said that they expect CPS systems, because of their complexity, to operate in fault mode most of the time. What has Siemens got to say about that?
Good question. I cannot really answer that. Okay.
We seem to have a short answer. I just want to ask a little about workers and they want to know what the situation can be. This is a kind of, I'm leading the witness of it with this question. But do you think there's a distinction we need to recognise between training and education? Because we're actually moving to a new paradigm now. And in the past, industry has relied on training and made it something different.
Yeah, yes, of course, it's different. I guess we need those. Okay.
Thank you very much indeed, Roland. We have another round of applause, please. Okay, so now we're going to move to some very fast presentations from the innovation actions of 2014. And we'll start with Paolo Go, who's going to talk about ADSIM.
Thanks. Everybody, my name is Paolo Gai from Evidence, and I'm going to give you a brief introduction on the ADSIM project, which is an idea started now 2 years ago. ADSIM was done. First phase, we are designing a small embedded board. The idea is to bridge together high-performance computing and cyber-physical systems in the single board. The idea is that we take the board and we connect it together to create a cluster. A cluster is a set of boards connected together to form a more powerful system. And the idea is that we are using the high-speed transceivers of the Zinc Ultrascale Plus, and we implement on top of it a remote DNA, which is memory transmissions between boards. Then on top of it, we develop a common programming paradigm based on OpenMP. In particular, OpenMP at cluster, which is OpenDSS at cluster, which is a product made by Barcelona Supercomputing Center to allow parallel programming model on top of clusters, and OpenDSS at FPGA, so that you can automatically accelerate your code into FPGA. Finally, we have use cases about video and audio processing, smart surveillance, and speech recognition. That is ADSIM in one slide. So, a few more details. The ADSIM board, here is the 3D prototype, is going to be assembled these days, so it will be available in a few weeks. The main things, it is a small board, 16 by 10 centimeters, Zinc Ultrascale Plus of the newest FPGA from Science, DDR4 and all the other things you may like to go to 12. The other things which are nice are that there is a camera input, there is a trace port if you want to do tracing using artifact or similar systems, and we can have power management probes attached to it to measure the power consumption. A close-up on the ADSIM link, which is the idea of connecting the board using the fast transceivers. We choose the USB-C connector, which is a high-speed transceiver for that. The board has been chosen as the innovation level finalist in 2016, and we were present at the ADSIM Maker Fair. You can see in the picture the small cluster of U2 boards with a visual tracking application running on it. Something about the programming model. We are using OMTSS. The idea is that you take, this example here is a matrix multiply. You have a few lines of code, and you automatically get the code optimized inside an FPGA. And you can see on the graphics that you can see very, really clearly, but there are 3 orders of magnitude difference between the optimized and the normal C code, and that's with just 3 lines of code. Finally, we are releasing a complete open to test the connector, the connection, the action link, emulated on QM. So the complete stack with drivers on PSS, Gasnet, everything installed will be available in a virtual machine in a few days. Actually, the deliverable will end today or tomorrow, so it will be a matter of days to be on the website. If you want more information, here is the website, and you are welcome to come and ask questions. Thanks.
Thank you. I'm just going to keep keeping to time. Are there any questions? We have time for that. No questions. What's your next step in terms of power consumption? That came up as a major issue in Werner Steinvogel's.
Yeah, here in the project we are going to take the boards and trying to optimize the power consumption using vortex scheduling and see now what is the impact of the FPGA acceleration compared to power. So we are doing coordinated measurements of traces of the software together with power consumption using the Autobahn for a simulation tool based on concept.
Thank you very much. Thank you very much. Okay, we move to our next presentation. This is Andreas Rokolakis, who is speaking for COSIM.
Good afternoon, everybody. I'm Andreas Rokolakis. I'm working for Simulation Solutions, which is an SME company, which is coordinating the COSIM project. I'll try to be fast. I don't know if it'll be as fast as the previous presenter. So this is a rough outline of the presentation. I'll try to tell you what we were thinking when we started the project, what was the problem we were trying to solve, and how we are proceeding with that. So a brief analysis of the current state of the cyber-physical systems demonstrates that they are very diverse systems that range from simple microcontrollers to very sophisticated servers. There have to be parts of the system that are plugged in, but other parts may be autonomous, they are operating on batteries, so power consumption may be crucial. They incorporate a huge number of communication technologies. They could be Ethernet, common Ethernet networks, or 5G, 3G technologies, or even other technologies for smaller devices. And as everyone has mentioned in the previous presentations, there are very strict security concerns. So when we were looking into that, we found that there is not an easy way or a completely graded method to simulate, to accurately simulate a total design of a CPS system, all of its components, the networks, the security stuff, things like that. There's a whole range of tools, which are mostly fragmented. I mean, one tool can do one thing, one tool can do network simulation, the other tool can do maybe processing system simulator, but there is not an integrated solution. And connecting all these things together, apart from being very slow, it's very painful for the designer. So what we are trying to do is to simulate a whole CPS system, and we are trying to do this concurrently, so we're doing it as a whole unit, simulating both the operation of each node in the system as well as the networks. When we are saying that we are simulating the CPS system, we are talking about the whole software stack, including the operating system, the system libraries, and the application, and also the hardware level, where we're simulating the devices. And also, we are working on the network side as well. The whole thing has to communicate with security tools, and through the whole simulation process, we provide hooks to whatever a security tool is going to need. The tool that we are developing is able to model devices at varying levels of details. Maybe if you are designing a microprocessor and you have all the details of the microprocessor, or maybe you are on a higher level and you just want an ARM low power processor. acceptable. We provide power and energy estimations, and we're doing that on modeling the devices on a lower level. So, and we are also using application statistics. Therefore, we are providing realistic estimations. We are not using dataset approach. We are working on accelerating the whole simulation process, either through parallelization or making it in a distributed way, or adding acceleration through specific devices. And we are working on a platform that uses industry-defined standards in order to connect components, and therefore we are aiming at making that expandable, and so that other people who have other parts that maybe we're not covering, they can connect it to our system. Our goals is to significantly reduce the time required to design and simulate cyber-physical system, to provide accurate results so that one can have confidence in the results that they're taking, that they are realistic. To reduce the design costs and the time to market, because we can provide accurate results, and offer security and robustness, software robustness testing tools to the simulation environment. So what exactly is what I'm talking? This is an abstract view of a CPS system. There are a lot of nodes. One node maybe is a simple microcontroller, the other may be the end server. They are connected through a multitude of networks. So for each of the nodes, we're using a modified version of the Gen 5 simulator, which is a full system simulator. That means that we can simulate the whole system. We can boot operating systems on top of the simulator. We can run applications, we can compile applications and things like that. And the power and energy estimations come from the MACPA tool, which is connected to Gen 5. For the network part, we're using the Omnet++ real network simulator, which can simulate whatever network protocol we want, and we can build complex networks with that. And to estimate the power, the energy that's consumed inside the network and the physical layers of the network devices, we're using mixing, which is an extension of Omnet. It's now totally integrated with Omnet. And on top of all those tools, there are some custom in-house security tools that have been developed by one of the partners of the project. And they are having access to all the components at whatever level. For example, if you want to access the register, the memory, the network, malicious nodes, whatever, you can have it through these tools. A more realistic view of the tool is something like that. Each component is connected. Okay, is connected through a standard XLA interface, and this all comes out like that. So, at the current state of development, the simulator is finished. All the main components are in place, and they have a common graphical user interface based on the one that is used in Omnet. We have two industrial partners, Tecnalia and ST Microelectronics, that they are bringing two applications to validate the simulator. The first one is a building management system, and the second one is a mobile visual service application. Currently, by using the HLA, we have managed to make every component able to run on a different machine, and therefore we can have a distributed simulation, and it's also made parallel. On top of that, we are working on accelerating certain parts of the simulation and we're using FPGA hardware to do that. And by using the HLA interface, we are trying to connect our system to cover more aspects through the Ptolemy physical process simulator. What the previous presenters today mentioned is that when we are talking about CPS, it's not really different than other parts of engineering, and we have found out through feedback that we have taken from events such as HiPic and others that the tool can become really interesting for people designing parallel systems and HPC applications. And the answer to the question what will happen is we are going to release the tool as an open source package, free, the core of the tool, and we're going to set up a spin-off to oversee the future development and also to cover some proprietary parts that are going to be device models, power models, and things like that. So, this is it. Sorry, I was out of time.
Thank you very much. Okay, so I think we'll move on to the next presentation. Thank you very much. So the next presenter is Ken Pierce, who's going to talk about Into CPS.
Hi, thanks very much. So yeah, I'm going to talk quickly about the Into CPS project. This is an integrated tool chain for model-based design of cyber-physical systems. It's coordinated by Peter Goldmarston at Aarhus University, who would like to have come today, but he's already engaged. So we have four academic partners, and the other of our 11 partners are industrial case study owners and tool providers. So the goal of Into CPS is to really provide a tool chain for connecting existing tools together to bring developments all the way from requirements through to code in a cyber-physical system. And we heard a lot today about the need for connecting models and multidisciplinary design, because cyber-physical systems have all these complicated processes. We have engineers who already have really good knowledge and really good tools that already exist, but they're often quite disconnected. So the core of Into CPS is co-simulation. We build these models connecting different models from different domains together to build more holistic models of systems, and that's really the core. But we also like to build a chain that takes people from requirements analysis, requirements engineering, through to this modeling part, and then continue all the way down through to code and hardware and sort of real testing. And over there we have this sort of loop going around, so we also like to, on top of this core chain, build sort of enhanced analysis techniques, including design space exploration, or some people call it trade space exploration, automated testing, and also provide traceability through the whole design chain by automatically, as much as possible, collecting traceability information. So the tool chain itself, I'll try and go through this quickly. So we have a tool called Medellio, made by Softeam in France, and that's a SysML modeling tool. And the idea is that you can capture your requirements, you can capture the architecture of CPS at this level. And then from that, we're able to generate, sort of for each bit of the system that's going to be modeled in a different one of our tools, we're able to automatically generate descriptions for that. Our baseline tools here are Overture, which is a modeling tool for VDM, which is some people may know. We also have 20sim and OpenMedallica. They're more about capturing physical processes through modeling of and simulation of differential equations. That's what I meant to say. We're using this thing called FMI, the Functional Markup Interface, and this, a bit like the previous speaker was talking about with the HLO, is sort of standard for co-simulation. So this defines how models can be put together. So by using an open standard, we're not limited to only these tools in the center. So we've already worked together with integrated some of the tools from Fortis, and we hope to have further things there as well. We also have RT Tester. This is Verified Software International, spin out from Bremen. They make automated testing tools, so people like Airbus are one of their big customers. So we're also able to generate test cases from this architectural model, and then provide sort of test oracles that are able to take part in simulations and give you sort of feedback and analysis there. This co-simulation stuff is all done by the co-simulation orchestration engine. So that implements FMI and is free to use. So that's out there these days. And in order to sort of give you a handle on this whole big tool chain, we have this thing called the Into CPS application. And this is really a front end where all of these analysis techniques can be sort of brought together and launched very simply. So I mentioned that we have 4 industrial partners looking into 4 discrete domains. So we have ClearSea from France looking at railways, and particularly interlocks that ensure that trains don't go on tracks. So we have Agro-Intelligence, who are working on moving away from large giant tractors that can damage soil onto smaller, more agile mobile tractors. United Technologies are working on a sort of smart building and building automation. Actually, my colleague Stelios is in the audience somewhere, and he can give you more information there. And finally, TWT out of Germany are looking at the automotive domain, and in particular feedback to drivers of electric cars. So a little demo here. So this is the SmartCPS application. So this is our front end. Okay, we'll skip the video. So a couple of things that we're working on at Newcastle are on this sort of design space exploration. So the idea is that at any point when you make a decision in your CPS design, you're essentially exploring what we're calling a design space, and you're making decisions further on down. So this is a line follow robot you would have seen on the previous slide. And here we have 1, 2, or 3 sensors. So depending on the number of sensors, the little robot's able to make sort of better or worse decisions about how it's moving around. And then anytime you sort of make a decision and say, oh, we're definitely going to have 2 sensors, then within that you've got parameters deciding where they're going to be. What we'd like to produce is sort of guidance and methodology for how, if you've got a really big design space that's larger than just a small robot, how you're able to use this sort of to find the best designs and how to assess them and so on and so forth. Videos aren't working, so I'll skip those. Final 2 slides. We have a large industrial follow group, so we have 71 companies who've signed up saying they're interested in results. And if you're interested in joining, you can contact my colleague Christian Koenig, or just find me afterwards. And we also have now an academic follow group, so this is more on the sort of academic side for dissemination, and my colleague Stelios will also help out. And finally, we're running a CPS summer school in July. This is with Lucien Braga University in Seaview. So these are actually people we met through the CPSE Labs project who were funded under an experiment. So that's their first European funding, so they're really, really happy to be able to do that. And we've joined together with some of the other projects, including CPSE Labs. And the idea is that you can just come for a day and get some really high-level important stuff, or you can stay for longer and get more detailed things. There's leaflets at the back, or just ask me afterwards. Thanks.
Thank you. We have time for one question, provided it doesn't take more than a minute to answer. Any questions? You get that off easy. Okay, thank you. Now we welcome Dominique Rego, who's going to talk about SCORPIUS.
Hello, I'm Dominique Rego from Paris, and I will talk about SCORPIUS. So, just to summarize the talk, I will introduce and talk about criticalities, then about project, and then about different aspects we've been monitoring. Then I will speak about mixed criticalities, industrial use cases, project partners, more information. Hopefully we'll have time to end this in the 7 minutes frame. So, in embedded system, as most of you may know, the current trend is that there is multiple architectures which are really now unavoidable for sake of many good capabilities such as energy efficiency and temperature integrity. Also, in the systems, there are a lot of heterogeneous solutions which are inside. Then for networking, we've got a lot of technologies. All of these need also a real-time response and have extra properties for safety, for example, in medical devices. complexity needs to be managed, and the project was about to handle these criticalities. So there are safety, data integrity, security, energy, temperature, timing, resource sharing. You notice that it's all non-functional, in fact, but it's additional needed in order to make systems work in some, I would say, more constrained environment than the current best effort systems, which are, for example, in mass media or mass usage, such as conventional smartphones or TV sets and so on and so forth. So if you want to address these markets, we need to add one or several of these capabilities. So that's what makes critical, because several of them may be available. So the SAFER project is about to create and apply a methodology to develop cyber physical systems and to consider these criticalities together, not individually, as it's usually the case for historic reasons, where safety market is very important, for example, in aerospace, and where security market is also considered mostly in high range isolation. But there we want to integrate these criticalities by design into the development process as soon as possible in order to assess how they can be balanced between one another in order to achieve the desired level of conformance. So basically the project approach has been to enable these criticalities by design across all levels of the system, from the hardware to the applications, and considering the fact that not all of the applications, as was said by Mark this morning, are applications on which you can, for example, have the level of criticality you want, but they are coexisting with applications which need to be operating in critical world. So this puts some constraints on the runtime environment, on the operating system, and also on the hardware. Besides that, we have a modeling and analysis activity in order to define how we can altogether take track of these criticalities and make sure they are well handled and implemented in the different levels of systems in a consistent way. So we have achieved the framework in the project where we have defined at the design level and at the execution level what are the elements to our knowledge which are needed to ensure these criticalities consistent. So it's still a work in progress, but it shows, this diagram shows where the elements are placed and how they are related to one another. So, for example, if we take the security aspects, what we have analyzed is the fact that you need to identify threats and the risk, and some key actions in the systems need to be addressed in order to provide security. You need to address secure boot, you need to address secure updates, secure communication, secure key management. So depending on the level of security you want to address, you will put some different focus on each of these or on multiple of these. Same applies to safety. You need to address maintainability, you need to address safety-aware runtime engines, and also all the normative elements which needs to be you need to conform to in order to have your product available on the market. And finally, we have also the integrity aspects related to timing, energy, and data, which need to be addressed. So right now, it's only one of these elements which are not mixed. And if we want to address, for example, mixed criticalities, we need to have some use cases where we assess what is the impact of one of the criticality onto the other, and what is the overall way of solving the problems. For example, here, it's when you want to address security and energy efficiency, you can have some cover channels which are arising from the fact that between two cores you get some information exchange which goes in the way you don't want it with respect to security. The first one is more secure than the second one. And there you need to address some mitigation techniques in order to make sure that through a temperature observation you will not have a power channel in your system. So we have also another use case, which is about mixed critical time scheduling. And there, again, you can have a low critical tasks which are QoS aware and can adapt to the context of the execution of high critical tasks. You can also have time-sensitive networking with frame preemption. So we've analyzed several cases like that in order to see what is the impact of mixed critical systems at design level. So finally, we have introduced clear use cases. One is about telecommunications, where you have a conventional smartphone which can host medical sensitive applications and normal ones in day-to-day life. So there are a lot of impact of this with respect to quality and security. And second, we have two automotive use cases. One is about multi-core handling of engine ECU. And another one which is network use case with time trigger deterrent. So, project partners are these ones. And if you want more information, because time will flow very fast when you speak, you can consult the website, blog, Twitter, and LinkedIn. And thank you for your attention.
Thank you very much, Tony. It's interesting that the issue of mixed criticality, although it's come up in one or two things, this first project was addressed it very specifically. Are there any questions for Dominique on this project? Yeah, hi.
A general question, do you have any links with the mixed criticality cluster? So the European Commission has a mixed criticality cluster?
Yes, I think we have a link to the mixed criticality cluster. We are in touch with another project which is in this cluster.
Thank you very much indeed. So we move on now to TACT project, and we welcome back Holger Diva, who's going to speak on that.
So, thank you, Michael. So I'm here in place of my colleague Christian Bigel for the company here today, and I'm going to read out the slides for you. Hopefully a little more than that. So this is the project consortium for the TAPS project. It's mining partners in 5 European countries, research institutes, technology providers, and also use case providers. TAPS is a 3-year project, now in its 3rd year, so running until the end of this year. TAPS is about the designing of an architecture for so-called open cyber-physical systems. Open means that they are extensible while they are running, so you can add instantaneously, add new functionality or update features on demand in the way that we all know from our mobile phones through so-called apps. Now, if you have that mechanisms, of course, quite advantageous because you can enable your product to keep up with latest technology, add certain features, but on the other side, you also run all sorts of problems with respect to safety, processing, security issues. So in order to allow apps to augment or extend your system, you need to trust them. That's why it's called the Trusted Apps Project. The way they implement this is by adding several layers of security in a village castle. And the layers of security exploited in TAPS are the following. So first of all, you need to have verified apps in the way that you are sure to that they behave correctly and securely. Techniques that enable mod-based development and mod checking of certain properties, and you have to have implemented trusted toolchain in order to generate those apps. Then you need to have a tailored execution environment that is trusted in various criticality levels. You need to have spatial and temporal isolation of the apps. Then you need to have fine-grained access control of the resources of the CPS devices there in order to ensure safety and privacy. The communication with critical interfaces have been managed. Of course, this has to be implemented on a trusted hardware that is specifically equipped with security mechanisms, and you have to have a trusted network in order to engage in secure and safe communication. All this is implemented on an architecture that looks like this in a simplified way. So at the top left, you have the application model that you want to implement as an app. Via a trusted tool chain, we generate apps, and also put them on the marketplace for the apps. And we have a trusted installation process that put those apps in the execution environment. Now, this execution environment is divided into three, say, domains, depending on the criticality level. There's a so-called rich execution environment where all the user code is residing. So this is the uncritical level, where you have like normal Android or iOS apps. And then you have trusted execution environment, where you have also apps that are then accessing the critical interfaces of your system. So you need to have an additional level of criticality here. And then, of course, you have the most critical execution environment where your most critical apps are residing, and you have special hardware support on the network level, also involving secure communication and deterministic Ethernet and the secure layer on the cameras. Two validation use cases. One in the mobility domain is an electric motorbike from Energica. What is tried out here is to check how to extend the features of that motorbike on the fly, so while it is running or in use. For example, you could activate optional modules like traction control or the adaptation of the braking system. So what you want to demonstrate here is that you can safely exploit additional apps on that motorcycle. And here's another use case in the healthcare domain. This is a trolley that the nurse would take in order to visit the patient in the hospital and to apply, for example, drugs to them. This is a smart trolley, so it has some kind of intelligent features. It connects to patient data, and it checks also the patient ID in order to ensure that only the particular patient gets the right drug treatment. And what is supposed to be demonstrated here is the secure separation of the critical applications, like the drug treatment, from the, say, more less critical application. For example, connecting to databases and for the patient data. The main achievements so far, I said the project running for 2 years now. So the architecture for SmartCPS has been established. The execution environments are foreseen, integrated safety integration there as well. There's a trusted toolchain for the apps that allows symbolic model checking of the programs that are generated here. There will be a marketplace to allow the storage of those apps. All sorts of technologies in order to enable the trusted communication and real-time execution of the apps are also implemented. And there's a little bit more to come. So overall, at the end of the project, it's expected to have this open platform for CPS, enabling multiple layers of security, execution environments with different protection levels, and integrated security and safety in real time over all of these layers with specific and dedicated hardware, network and virtualization, end-to-end security, and also trusted processes to boot, install, and operate the apps. And all this will be evaluated and validated in 3 application use cases. The third one that I didn't mention is on an industry audit server use case, but this is coming up in the 13th. Thank you very much.
Thank you. It's time for one question, if there is one, to Holger. Thank you very much. Oh, sorry, go on, yes, please, Charles.
You mentioned multiple layers of security, and one particular area that I noticed you have mentioned its criticality a bit earlier on, and partitioning. What often you is partitioning more at the hardware easy way out of this question for me would be to say, I'm not involved in Dutch projects, so I really know. But that's our trust zone makes sense to you this way. So this is technology that's exploited on the hardware level. I'm not sure about the details on the software level. Maybe Harold can add something?
Yeah, the operation code. Operation code.
Is that separation code?
Thank you very much. Okay, so we now move to our last speaker for this session, which is Shaukat Ali, who's going to talk about the UTEST project.
Cyber-physical systems, or CPS, are the next generation of interconnected embedded information and communications technology systems. Cyber-physical systems work in many areas today. The market is estimated to grow from $32.3 trillion today to $82 trillion in 2025. UTEST is designed to improve reliability of CPS, where automated warehouses and connected healthcare products and services are chosen as pilot cases. Due to increasing regulations, the costs of testing and quality assurance in medical devices development are swelling. The costs will grow further as emerging healthcare systems and services become more interconnected in the cyber and physical world. UTEST develops cost-effective, robust and efficient testing methods for CPS operating in uncertainty. By using these testing methods, we can guarantee that cyber-physical systems can handle uncertain situations. On May the 7th, 2016, Tesla's self-driving car caused a crash. It suddenly changed lanes and put itself in the path of a large white trailer. The car's software had not yet encountered the combination of bright sunlight and the bright reflective surface on the trailer. Thus, there were no protocols to escape the situation. The crash was caused by the system failure. It is a hopeless task to simulate and foresee every possible uncertain scenario in such a complex system. However, a lot can be done to improve the system's reliability before it is placed in an operational environment. The self-driving car is a cyber-physical system. It exemplifies the kind of challenge that the UTEST methodology aims to improve. UTEST uses its methods and tools to test the cyber-physical systems in healthcare and logistics. The tools and methodology developed for UTEST sets a new standard for testing and quality assurance of the CPS. When CPS complexity increases, the product needs to meet the highest standards in terms of both reliability and compliance. Our team has developed a framework that provides a complete environment to deal with uncertainty during testing and to automate test generation and execution. This methodology generates a higher amount of test conditions and enhances the reliability of the CPS compared to traditional testing. The UTEST methodology can validate the CPS behavior in a wide range of scenarios, such as changing temperature and blood pressure. In fact, anything quantifiable can be tested. The consequences of failing to thoroughly test these new devices can be devastating. For example, a lot of people have pacemakers. Pacemakers are known to fail under certain circumstances. For instance, when used by people they weren't originally designed for, like younger patients. Traditionally, the testing methods have been too expensive and ineffective. Relevant test results and protocols are therefore missing from the pacemakers we use today. By expanding the range of medical equipment are tested against, UTEST can radically improve their robustness. We're only at the very beginning of CPS deployment, and we expect to see a massive increase in devices that have advanced software and are connected to the web. UTEST aims to reduce testing time by at least 30% and to increase the number of tested user scenarios and related risks by 20% on all CPS software. The UTEST methodology will save time and increase robustness in the products before release. Most importantly, UTEST will improve the quality of the software by identifying as many uncertainties as possible and addressing them early in the design phase. That basically is what our program does. To make this happen, we have collaborated closely with many talented people. To learn more about us and
by dedicated half So I think the goal and the objectives of hopefully the project are clear to you, that we are trying to test cyber physical systems in uncertainty, because uncertainty is inherent in cyber physical system, because they interact with physical environment, human, and all those things that you cannot predict at the design time. So these are the project partners that I already mentioned, and what we want to do in this project is that there are several aspects. First, we want to understand what uncertainty is in the context of cyber physical systems. So we define a taxonomy to precisely define uncertainty at the different levels of cyber physical systems. We have devised a modeling framework which is extensible and configurable, and this modeling framework is specifically designed to support automated testing. So it's called model-based testing. And then we have testing framework where you can plug in different kind of uncertainty-aware test strategies. We can do test optimization, we can do test case generation, and we can use test case minimization and so on. And we are also focusing a lot on standardization in this project. So we are using model-based testing. Models are the core of our overall methodology. So all the test rating models, all the uncertain situations, they are modeled using UML, extensions, and so on. We use search-based methods, for example, genetic algorithms and their variations for multi-object optimization, for example, NSGA2 to solve various optimization problems. So we try to even discover new kind of uncertainties by encoding our models into input for these kind of algorithms, these smart algorithms, and try to generate new scenarios out of these search algorithms. So we have two tool chains in the part of the project. We have certified, provided by smart testing, and we have defined a very nice complete tool that you can use to define your models. You can generate test cases, you can execute test cases, and then based on the results of the execution, you can discover new kind of uncertainties that you can later on use to protect your system implementation against those kind of uncertainties. And second, we have another tool support with us from Tron for Focus, which is called Focus MBTP. And so far we have uncertainty modeling framework, which has different kind of profiles, model arrays, and guidelines. We have a testing framework where we have defined a variety of test strategies using multi-objective search. We are contributing to standardization of UML testing profile version 2. Also, we have started a new standalone uncertainty working at object management group, and we are also contributing to system modeling version 2 by contributing uncertainty requirements into these standards. So we have given this webinar last week, so you have to go and check what we are trying to standardize in this particular standard. And we have so many participation in the last week, and please feel free to go, and if anyone is willing to contribute to this standard, please feel free to contact us. And we have already identified various potential revenues in the project and various kind of products, and we have business plan ready from the project as well at this point. So that's all.
So, any questions? Hi, first name, gentleman.
Okay, I have a question on your video you had about heart pacemakers, which is quite an interesting one, because my understanding is that there's a lot of different programmable things you can have in a heart pacemaker, but when they install them, they always use the same one. So that most people go around with pacemakers that aren't actually configured to them.
Yes, so actually the example that I presented is not our partner use case. So this was one of the future applications that we are looking at in this case, where those will be connected, and they will be talking to the system. So I guess that was the example that was provided. But in the context of our project, we are not touch pacemakers at all. Actually, we are working with another application which is called GeoSpores, and they attach different kind of sensors to the band deploys hockey players and monitor their health conditions and weakness and so on. So we didn't touch it, was just an example.
Okay, thank you. One more question.
How is your standardization issues are? Because here is the IEC 6061, which is reference for the European Medical Device Directive.
Yes, so in our case, we are focusing on software modeling standard. So that's why we, since GML is one of the standard in object management group. So in our project, we are focusing on creating test models. And as part of test model, we want to
example, UML or in the form of another meta models. So our standard is only focusing on just the modeling aspect of consulting.
But you are not looking at the safety aspects
No.
of the designing,
No.
let's say, code or something like that.
No.
So thank you very much again, and thank you for all the speakers in this session. We're going to have a coffee break now, and we'll reconvene at 5 to 4.
Okay, so we're going to start the next session now. So again, starting with a community presentation. As I said before, we're going to be having these ICT1 presentations, but also some from the overall community. And you missed all my nice words in the morning because I have been talking a lot that Artemis is very supportive to the ICT1 community, that we like doing events together with you back to back, so that Artemis is having. And then tomorrow too, which you might know, if not, you can still register, I guess, to the Broadway event.
Absolutely.
And yes, so Artemis is doing the big agenda, I would say, the strategic research agenda. So this is the one you're going to hear about, influencing very much the Horizon 2020 program. And as Werner said in the morning, also most CPS projects are within the Excel program, but some also in the Horizon 2020 industrial leadership. So I'm looking forward to you, Matt.
Thank you very much, Michael, for your kind introduction, and indeed, thanks also for the advertisement for our brokerage event tomorrow in this very same hotel. And we hope to welcome quite some number of people. I think we have already 270 registrants. I think I will do some talk because you know the last numbers. And I would like to give a short introduction on the Artemis Industry Association. And I suppose you all know Artemis. I will say only a few words. We have a new association here. It was launched in April in Vienna, co-located with CPS Week in the Hofburg. It was a beautiful place and a beautiful time to launch this SOA. It's a new rationale, digital transformation. Also, the Commission is very much on this in this area these days. We have here a simple picture, although this screen seems a bit squeezed from the right and the left. But you see here the transformation that came from a lot of mechanization to mechanical engineering, digitization, and then integration to connect the system to cloud and ecosystems. And this way you see electronics added to a product, and later on the electronics go even to services instead of only the physical things. So the sound physical systems are the key driver in this digital transformation. They are not only the computing hardware, they are also connected with other sound physical systems. And the main trends that define this new area is the integration of functions, not only within one application area, but also among several different application areas. And I think the mobile phone is one of the big examples of that, which becomes kind of a multi-tool. Open platforms is another very important element in this. If you don't have an open platform, such a thing cannot grow, cannot expand. The combination of internet with information stored in huge databases is another element of it. And it also means that you connect automatically to big data type of things. So a number of these drivers, the always connected society is a very important one. The virtualization of communities has changed our society. People are now always connected to all kinds of information sources. The platform concept which creates this hyper-scalability, as you can see, for example, from Google, from Skype-like businesses, this platform really makes it possible for companies to take off very quickly and very, very fast. And then the data dilution, as they call it, the data value, the enormous amounts of data which are there, but are not used in all cases and all ways. Then security, of course, also mentioned this morning several times. I think security is one of the big issues. Privacy is a very important thing, certainly when you talk about platforms. And also the software value. It's not only the hardware that makes the systems, but especially the software that connects everything together. And as I said, trust and privacy is the other important driver. This picture you did see also this morning in the High Peak presentation. We also use it because it's a very, very nice picture, which indeed shows that all these elements are connected together. They're not standalone. It's not only networks, it's not only big data or computing or services systems. They are connected together in a very important way. So I think it's very important that, no, I'm too fast, that this indeed is considered in this way, and cooperation is key to this. Of course, each of these elements needs research in its own respect, in its own art, in its own domain, but also it's very important that people look over these boards, because when you want to build an open platform that is successful, you need to do this. Otherwise you will not be successful. One of the thinking threads of the Archivist Innovation and Strategy, the SRA, the priorities are this picture, which shows that a number of building blocks. Then you have standards and interoperability. That is going to work. You have a number of building blocks that you can use for CPS. Then that means that you also need standards and interoperability to make sure that they work together. You need a lot of know-how for that, and engineering tooling and engineering knowledge. And then, of course, the architecture then creates something that you can recognize and really use. It makes it functional. So this is what we call a set of elements across the system design, flow, and the supply chain. For the supply chain, you need also these building blocks. You can hardware, can be software building blocks, but you need then these standards and interoperability to make them indeed work, and to, in the end, form architecture that can really support products. And in order to break these domain barriers and also boost innovation, research activities should really continue to foster a cross-domain approach. As we already put in our first SRA in 2007, and then it was quite new. In Archivist projects, we have seen that it can work. You can combine the different mobility domains in one project, and that works out. People find similarities, people find synergies, and in the end, that should also happen, I think, at higher levels, not only within the mobility level, but for example also between, say, something like manufacturing and mobility. Because IoT type of applications will not only be, I would say, applicable in one domain, but also will proliferate to other domains. This is an example of how you can create then, I would say, kind of house, and I think it's quite unreadable if I look to the beamer here, but perhaps this presentation is later on distributed. It starts with the basic research, of course, then the methods and tools for the engineering and virtual engineering, then the robustness and availability and the interoperability, and then here you get into, I would say, the more architectural part, systems of systems, computing fabrics, things of the internet, and also CPS architectures. That is then topped off by digital platforms that can unite these kind of subjects, and of course you need businesses and ecosystems, which is also a separate topic on itself, but it's built on all these elements. And only when the elements fit well together and have a good glue, then these businesses can really flourish. So the message here is also that these CPS components, convertible CPS components, can maximize reuse, but also accelerate development and consequently time to market. This is also our cross-domain approach, where you see a number of topics that hold for example, smart mobility, health, communities, but also production and energy. Digital platforms, as I said, mobility, connectivity, but also the architectures you can share, and then also for computing elements. And then also the supporting elements of dependability and methods tools, of course, are part of this picture. Then this is the context in which I was also present in this big circle. If you have the services, the products, and the digital products, this is the automotive products, and the digital products, and circular products, that's the Internet of Things plays an important role. Our SRA tries to cover everything from hardware until these services, but also the elements as big data, high performance computing, but also robotics, 5G, and photonics play a very important role. It should also be considered in concert and not only in isolation. And then a bit about Artemisia. This picture is from our website. If you scroll down on our website through the lower end, you find this information. This is still about the Artemis JU projects. In total, about 56 projects with 770 partners, 6 calls on a number of topics. Artemisia has 8 working groups and quite some members about. It's here still 174, but I think we are now again at 180. So we have this kind of information on our website, and in the future also the Excel project should be part of this, since our members are currently very active in Excel projects. Although it's spread over different projects, which from which the projects are not, I would say, really CPS projects. So there are CPS elements in each of these projects, but our members are still, as I said, quite active. What's very important is in Artemis we had 3 innovation pilot projects, the AIPPs, which proved to be very useful. They were big projects between 80 and 100 partners. These projects showed indeed that standardization and interoperability were very important. They brought a lot of people together. I think this can still work. In Excel there are lighthouse initiatives, which also go in this direction and perhaps even on a higher scale. And we look forward to see what comes out of that. And Artemis Industry Association organizes about 3 or 4 events, community events each year to bring the CPS community together. And we do not do that on our own. We like to also cooperate, as for example, as I said, the co-location with CPS Week, the cooperation that we have with local CPS in combining events in the same week and preferably in the same location, and it all helps to gather critical mass and bring people really in contact with each other. Then the 3 focus areas of Artemisia. Last year it was decided to not only focus on embedded physical systems, which is really the heart of Artemis, but also to add the Internet of Things to it, because the communication becomes more and more important. And Internet of Things is a very important element in that. But then also the digital platforms, as they are supporting infrastructures to really make things alive, to really build, I would say, the creation of the digital economy on. I think also the Commission is very active in this. In the next few days we have a kind of stakeholder forum in Essen to discuss about this. So we are very unfortunate that it's impediment to our event, but we are very fortunate that this idea now goes wider. This is a bit of the structure. As you see, we have a kind of innovation environment, what we call it, which is the heart, which is the working groups and labeled Center of Innovation Excellences, and a lot of Excel partners and a lot of other partners in cooperation with support actions. Then of course we have a formal structure with a General Assembly, steering board, and then a lot of support by the office and presidium. But I won't bother you too long with this part. If you want more information, you can find it on our website. And if you have any questions, I hope that I have left still some time to answer them. Thank you for your attention.
Thank you very much. So, open for questions. So you have been very, very clear, but maybe no question from the audience? Okay, so if you want to have a deep dive, you can go there tomorrow. So starting at 1 o'clock, I think.
Yes, it starts
Same
after
as
lunch.
you?
It starts in fact with lunch.
Okay, with lunch. Okay. All right. So excellent.
Okay, thank you.
Okay. So we're now coming to the ICT 1 2016 project.
also parallel to this, we are seeing more and more companies acquiring expertise in terms of artificial intelligence. Not only people, but also resources that are out there. This is one size. The project, basically, we want to build a data marketplace that's right at the center. There, the idea is to share both data and models. Models come from data. Basically, you train models from data. This, of course, has to use a huge amount of computing power. That's on the lower left corner. As for data, there's not only the data that comes from sensor. You will also have some tools to create additional data. Sometimes you can create artificial data, and that's useful too, because in the end you have more and more data. Also, the idea is to develop some developer platforms which are more like the physical thing that you are going to use to develop a specific system. And at the end, we will have some systems of artificial intelligence that, using one development platform and using those artificial intelligence models, will create some new products and services. Within the project, we will have 4 basic demonstrators in the automotive, consumer, and healthcare scenarios.
Thank you very much. So, any questions here?
I would like to know if the data that you will expose in the marketplace is just open data or also closed data, and then if you will also deal with payment transactions, since it is a marketplace.
I don't think we will deal with payment transactions, and as for data, I guess that's something that we will define in the future, but I believe it will be open.
Okay, so further questions? Okay, now we're going to move on to Francesca from the University of Sassari with, I hope I pronounce it right,
stands for Cross-Layer Model-Based Framework for Multi-Systems in Uncertain Hybrid Environments. And these are the keywords of our project, basically. In fact, we want to adopt a cross-layer optimization approach, meaning that we are going to take into account all the three different layers, computation, communication, and the physical one, following a model-based approach. Actually, we are going to study semantics on how to model these different layers, and we are going to define model-to-model transformation and model-to-model interfaces to take into account the differences of these layers. We are speaking about optimization because we want to derive some generic key performance indicators that will be capable to be adapted to the different scenarios, and we are going to take into account systems that need to that presents uncertain parameters. So the behaviors at runtime is not predictable by design. On top of that, we have found that at the state of the art there is still some lack in modeling adaptivity. So one of the goals of the project is to design a runtime engine capable of being able to answer these needs for adaptivity. The consortium is composed of 12 partners from 7 different countries. We have 3 large enterprises, 3 SMEs, 1 applied research center, and 5 universities. And the idea is to create this framework based on these 3 main big assumptions that are in fact that we want to provide a model-centric approach to scenario and system and parameters of the system definition, a runtime engine capable of providing hardware and software adaptivity, basically exploiting sensor-driven and sensor-driven information. And all these two things are going to be summarized in what we call the continuous design and operational framework. It is composed of basically on 4 different components that are optimization components, verification, in-loop simulation, and prototyping components. Where we are at the moment, we actually had our kickoff meeting 2 weeks ago, and this is the result of our kickoff meeting, basically. We have identified all the tools that we think may be useful to describe, to be integrated in this cross-layer continuous operational framework. And we divided them according to the different layers to derive the system and to be able to describe the system from the requirements directly to the prototyping, to prototype the demonstrators. What comes next is the fact that in the next month we are going to speak with the different use case providers in details to define what are the features of all the set of tools that we have identified that basically are important for them and that needs to be developed. These are the 3 scenarios that we have already, where we are going to provide demonstrations of our tools. A self-healing system for planetary exploration from Thales Alenia Space. Ocean monitoring from an SME, UK SMEs from Ambisons, and smart traveling that is going to be provided by TNO, the Fiat Research Center, and Abusula. You can follow our project on our website that is already online as a beta version, and this is the contacts of the people in the board of the project. That besides me includes Michael Mason, that is the coordinator from IBM, Katusha Sella from Abusula, that is here today with me, and she's the innovation manager of the project, and Francesco Regazzoni, that is the communication and dissemination manager of the project.
Thank you very much, Francesca. Well, maybe there's questions. So questions from the audience?
Sinclair University. Can't see where the boundaries of this project are. One of the things that you said is that we're talking about reconfigurable systems.
Yes.
Does that include systems that are not physically configured until runtime, for example? If you've got that problem, then you have a verification validation problem.
Yes.
You also have a payments problem working in all of this. How are you proposing to handle these, although they're not part of this?
Okay. One of the things that we are starting to study at the moment, and some of the people in the consortium, like University of Rennes, has already some experience of that, is how to model reconfigurability. So a model-based approach to reconfigurability. So we will integrate in the runtime engine these models that will somehow define at runtime not somehow. I mean, we are we just started this month, but the idea is having these parameterized data flow models, for example, within the runtime engine, in order to have some task supervisor that will be capable to partition at runtime what is the things that the software or the hardware has to do.
Okay, another question from the audience? Okay, thank you very much. So we're going to continue with the next speaker. This is CPS Forum, so Riccardo Tomasi from the ISMB.
Good afternoon, everybody. I'm Riccardo Tomasi, and I prepared this presentation together with Fabio Bostonor, the coordinator. So, CPS Swarm, in a few words, is a recently started project under the ICT 2016 code. I must start with a confession. I'm extremely happy about the presentations that I saw in the previous session because there are a huge number of point of contacts between the project that have been presented and what we're going to do in the next 3 years. We have, on the other hand, a slightly different approach. So, starting with the consortium, we are 3 applied research center, 1 university, 2 large enterprises, and 2 SMEs. As I said, what we're doing is extremely similar to what we saw so far. So, we are also working on a complete solution for collaborative and autonomous CPS and CPSOS. We cover all the parts of the life cycle, going from the model to the deployment. What's the original part of CPS Swarm? So the vision of the project actually started with an idea, and the idea is that with a growing number of smart CPS being deployed in the field, at some point we're going to see some emerging behaviors. So we imagine a world where we're going to have a large number of intelligent autonomous systems, which independently they are maybe smart on their own, but at some point we're going to see some emerging behaviors that is probably not foreseen. So if you imagine, for instance, a line forming up of cars on the highway, each driver is probably intelligent enough, but when the traffic increases, each one braking, resort to a behavior that is globally not optimal. This is something very difficult to control, also because, as we saw in the previous presentation, our environment is extremely open. There are ways, of course, in automation to control the looping systems, but there everything is very well known. CPS Swarm, in order to tackle the problem, tries to reverse the problem. So instead of trying to counter emerging behavior, we take them as our basic design principles. So the project basically builds a toolchain for designing CPS that can be part of swarms. So we start from models libraries. Of course, we're not going to invent new ways of modeling or new models for things that already exist. So we start from state-of-the-art models, and we which is basically oriented to small computing. So we try to define goals at high level, and goals are assigned to swarm. And we try different configuration of devices which can run in a simulated environment and multiple times to find the approach that better fits the approach. So the idea is that the developer can, starting from a high-level problem model and iterate multiple times in simulations to find a perfect solution. When sufficient quality is achieved, we go into the deployment part of the project. So we have code generation facility and deployment toolchain to perform real-time deployment and configuration of control features, which allows to basically to deploy control to swarms of devices. This is just our objectives to extend our KPIs. So basically, we take those to improve the design of complex autonomous CPS, deliver libraries of models which can be reused. So starting from what already exists and released in another environment, and tackling reduction in time and complexity of development. Also develop and extend existing methods of control algorithm for swarm computing, and also establish and improve existing reference patterns and tools for integration of CPS artifacts. We basically work in three main scenarios. So as you can see, the project is very technical. So in order to avoid being lost too much in the sky, we follow three concrete use cases that are used to drive the whole development of the toolchain. We have a use case on swarm drones, so basically populations of drones and robots used for surveillance and security applications. We have an automotive use case, which basically tries to deliver the electronic crowbar and other similar kind of applications, and one swarm logistics applications focusing on new ways of manipulating goods with robots. One last aspect is about the methodology. So the project itself, but also the kind of methodologies that we are studying at the moment, look at alternative ways of working. So the good point of this methodology is that you will see probably results, practical results from the project release since the first year, which will be then improved in the subsequent years.
Thank you very much. So, questions from the audience.
So I was wondering how many drones do you have in these swarms of drones that you have, and how many other cards are they connected to that?
You mean the demonstrators or in
I'm just curious, what is the scale?
Well, in general, of course, we work in an environment where the number of drones is not exactly set in the beginning. As far as the project is concerned, we will run a demonstration with small scale, of course. This is not a demonstration project. So from the pilot size case, we look at situations where we have maybe under 10 drones.
But isn't this a problem? Because, you know, we all do experiments on, 3, 4, I mean, we always did experiments on 1 robot, 2 robots, 5 robots, and so on. Now the question is, does it scale to 1,000? Does it scale to 1 million? Does it scale to 1 billion? Does it scale to the teraswarm? Because this is what we are going to ultimately. Because the question is, are our models appropriate for this? Because you build one model for 5 drones, and you need a totally different model for 1,000 drones.
Yeah, it's a very good point. So for that problem, we basically use the simulation environment. That's the plan.
Yeah, but your simulation environment is going to fail with 1,000 drones. I mean.
Yeah, but that's what we need to see.
But it's not your fault. I'm
just
asking a question.
No, but we already discussed the problem more or less. What we will try first is to perform hybrid simulations in case where maybe we have one or two drones under development, which we look into details, working in a situation where we have an environment made by also by other drones, which is scale up already large enough for the past. But this is of course an open challenge, so I agree it's a very good point.
Hi, but indeed this is an open question in all presentations that we have seen previously. In general, all case studies are focused in cyber-physical system with heterogeneity but with a low number of components. This is not only this project. In general, all projects that we have already seen all the morning, we have seen heterogeneous cyber-physical system but with a limited number or in the heterogeneity or in the number of systems. So definitely is a topic that we have to explore. I'm not involved in this project, but it's quite common that when you review projects on this area, we can see that the number of subsystems that we are going. For that reason, the states, they prefer to concentrate on system rather than on cyber-physical system. I can remember one slide of the morning in which cyber-physical system is a sub-circle inside a big one. So indeed, we have to explore. And it's a topic that we have to address in the next years because it's not straightforward to address design of such kind of complexity.
You can talk later. Just a short answer. We are verifying systems with 100 lines of code for 40 years. We never scaled up to 1 million and 2 million, okay? And I think that one has to be on this from the very beginning.
To be continued, I guess. But I think here we're also going to continue, so thanks a lot to you. So we're coming to the CSA program, so the 2016 CSA, which in a way is going to be continuing the work of Roger CPS. So as we at least as Steinways are also partnered at CSA, we're going to have some continuity there, so we're going to keep mailing to you. Yes, this one has a bit more of a focus on platforms, because platforms was very important for the European Commission, and it's called Platforms for CPS. Coordinator is Thales and Charles Robbins.
Okay, thanks, Michael. Hello, everyone. Indeed, this morning we're talking about some roadmap projects which are coming to an end after much effort, but the show must go on. So we're continuing this with Platforms for CPS, creating the vision, strategy, technology building blocks, and supporting ecosystem. And I should emphasize when we say creating, we're looking more at building on and updating the roadmaps that are out there. I think this is a very important key aspect to take into account. So the consortium, this is more of an introduction as we're just starting off the roadmapping project. But we've got people from the UK who have a background in, for example, advanced sensing, wireless data acquisition and control systems, and they're very much involved in roadmapping projects. From France, we've got Systematic, who are a hub for SMEs, in particular for embedded systems, and they've got domains related to healthcare, transport, and manufacturing. Thales, we're coordinating, providing an industrial perspective. Some of our applications include training system development, embedded intelligence, and system integration. From Stream, we've got KTH, the Royal Institute of Technology, and they're providing a research perspective, and the particular team that we'll be working with have a background in mechatronics and embedded control systems. From Germany, I'll providing two perspectives. So one research and also one in terms of technology transfer, and in particular for software-intensive systems and services, if I remember correctly. And then to keep us on track, we've got Steinweiss continuing into this new project, and they've a strong focus in technology transfer. So then the objectives are pretty much contained in the title of our project. We're looking at analyzing the ecosystem, looking at market perspectives, and as I mentioned, updating and validating existing CPS roadmaps across several domains. Platform building is another important aspect we'll be looking at, and especially community development and integration. So we have here just a nice picture representing that aspect. So the pillars for this project, the strong points that we're going to be emphasizing are the CPS and industrial IoT landscape, road mapping and recommendations, platforms and opinion-oriented activities, constituency building and collaboration, and of course the dissemination and exploitation is very important. So these take up the work packages, which are led by Tally, Steinweiss and Fink, and then the particular tasks are shared out between the partners across the work packages. Outputs from the project include market analysis and recommendations for business opportunities, CPS community roadmap and recommendations for research priorities and innovation strategies. We're going to have a survey of CPS platforms. Also, we plan to have a repository of building blocks for platforms in the CPS domain. Showrooms for platform arenas. This will be looking at examples of platforms, and there'll be particularly a strong input from SMEs to indicate how they can take more participation in terms of industrial large platforms. We've also something we've got called the platform, which will be the engagements with the community and finally constituency building and clustering groups. So impact is going to be particularly in the form of catalyzing nature, bringing together previously independent stakeholders, separated stakeholder communities. We'll also be looking at connections with IoT, ICT, communications, 5G, and identifying gaps and strategic directions with respect to platforms, strategic research, and other important points that we discussed. Contribute to constituency building and thus promoting longer-term efforts and ecosystem building. And then the last 3 points, gathering and disseminating technology blocks and platform-intensive practices, steering initiatives and efforts towards identifying strategic directions, and sustainable platforms for CPS alliance. So short and sweet.
Thanks a lot, Charles. So, any questions from the audience? Okay. All right. So then comes, last but not least, not one of the new projects, but one of the ones which has been running parallel to us, the third CSA of the 2014 calls, and this is CPS Summit. It's presented by Hannah Luz from Fortis, and it's also on US collaboration like the TAMS project has been. So they have been really running parallel with the same theme, but TAMS was more on modeling and simulation, and CPS Summit on CPS as a whole. Hi.
Thank you very much. Always a pleasure to So it was a rather small coordinated support action with the goal of facilitating training during sustainable collaboration containing CPS research and development between Europe and the US. And the unique thing about it is that academics, industry, and also lots of funding agencies, national funding agencies in Europe, and also all of the funding agencies except for one in the US were participating in that effort. And most of the results of the workshops you can find here on this CPS BO page, which is an American thing run by the NSF. And that keeps getting more and more popular also with European projects that have their websites there. So one of the outcomes of this collaboration is that actually if you decide to have something similar in Europe, like this CPS virtual organization, then our departments will actually support us, technical support and all the experience that we're having in the past. I think that would be a valuable thing to have eventually for community CPS in Europe. Okay, I don't want to define CPS, but I mean this landscape here actually describes quite well what we want to do. So CPS in this view is pretty much what was in one of the slides in the definition, origin definition of IT, the kind of the convergence of engineering methodologies from the cyberspace and the digital space. And it actually translates to a couple of foundational challenges, which the long list, it's also not exhaustive here, that's the first observation. Second is, there's nothing really new here, right, from that perspective. But if you let's say look at the dependability of fault tolerance, and of course we have lots of methods there for embedded systems, how to deal with that, redundancy and so on, like tolerating, let's say, one bad idiot. You can do that with embedded systems, but you cannot do that on running Terraform scale anymore. So we need radically new science here. And similar observations are here. So things we don't have yet, right? On the other hand, we're building that stuff, right? The Internet of Things is there, cloud computing is there, all these platforms are being developed. And the real challenge actually is to build these things in a trustworthy way. I'm also repeating here what I think Michael said that this morning, right? So trustworthiness of this system is kind of the overarching challenge. How to do that? Just to give an example, so a recent distributed denial of service attack has been accomplished on an Internet of Things kind of platform, has been accomplished by hijacking a sizable number of baby phones. They were vulnerable, and you could bring down the communication infrastructure of half of a country. So everything's connected to the data. On the other hand, in kind of more safety-oriented domains like in avionics, right, you can build lots of new prototypes and new prototypes, new demonstrators, but we don't bring it in the air because we cannot certify them. Right? Also, kind of this trustworthiness issue is missing, and also
different perspective on the margarita as given before. Okay, so common challenges. So if we put a bunch of people together, what do they suggest? Yeah, this is a call to launch a synergistic research campaign for solving cross-cutting scientific challenges and cybersecurity systems for building trustworthy CPS. Okay, and I don't go into politics right now, what's going on right now. But that will change, don't worry. So we put up an action plan, actually how, kind of a blueprint of how such a collaborative effort should look like. A couple of contributors, editors, so it has been edited by Maradam on the European side and Janusz Michalowicz on the US side, and a couple of contributors are here. You can download it here. It has been a featured report on the CPSCO title page for the last half a year, which we are very proud of. So it also shows kind of the commitment of the Americans to make this thing happen. That's also one of the insights. And I don't go into details here why we should do it now. Maybe we should wait a couple of months, right? Looking at the newspapers. Why we need to join forces, and so on. And the main thing is it's distributed in 4 action lines, which already kind of joint research. Those are the topics: driving horizontal standards, open platforms, and living labs. So CPS is about building stuff. It's not about putting Greek symbols on the paper. It's about building stuff, and we need this large-scale experimental platform also to address Radu's concern that we stick with small use cases, not going to the Terraform. And exchanging best practices, also a very innovative concept here for connecting recent research with education in a very nice way. So also, I'm actually third time I should do that. So Radu is one of the cores on that one. So if you have more details, it's next one. On it. And so the recommendations are, of course, implementing this action plan. For that, we need kind of a novel mechanism of strong collaborative effort with joint proposals and joint evaluations. Everybody who has ever suffered through one of these binational calls will know what I'm talking about. It builds on the shoulders of giants, right? Huge programs in the US and EU. Werner already knows you on that one. And it should also be aligned with industry-driven programs like Excel, the Industrial Internet of Things, and of course also aligned with Artemis. This thing needs a coordination effort. Of course, this is a big thing, and we should start early, and we should jumpstart with kind of 2 aligned twin projects. Could be a manifest expedition project on the US side, or maybe an Excel effort on the EU side. And the main thing of such a main result would be kind of a set of building blocks, real building blocks across domains, pretty much in line with what Martin Burke just said about the Artemis research agenda, right? Pretty much in line with this research agenda. And of course, a first set of design principles
have to listen all day. I already asked him if his head is exploding already with all that information. But we have tested this in other events, and he is brilliant in that, I must say. So you to see now. So summarizing everything, there will be a report. Of course, that report will be more detailed than what was captured right now at the moment. But for you to see, before 5:30, I think you will have heard everything from him. But then, even if the event closes, then you're still free to discuss until, let's say, 6 or something. So people who want to stay can stay, but you will have heard everything by 5:30. Okay, so hey, Thompson.
Okay, well, good afternoon. The first thing I'd like to say is I'm quite impressed by the number of people that are here today, because at the consultation event, you've managed to attract a lot of people to this event. I think that's very important, because there's a number of these events go on, and quite often we don't get the sort of participation that we'd like. But certainly there's a lot of interest in this event, and it's very nice to see all the projects contributing to this. And also such a range of diverse applications as well, which I think is also very fascinating as well. So we've seen a lot of things today. This has been the rundown of what we've seen, but actually you've seen a lot of presentations. So we're starting off with the European Commission talking about strategy and vision. We've heard from industry. Siemens has spoken about their sort of priorities. We've also heard from the Artemis Industry Association, which represents 170 different companies around Europe, so that's quite important to see their strategic research agenda. And we've also seen a number of projects. We've seen the We've seen the project from 2014, we've seen the research and innovation actions, where there's a number of things going on there. We've also seen the latest project, which has just been funded and which has just started. And it's quite interesting to see the way the themes have changed over that time, because you can see subtle changes going on, which actually match some of the strategy which is going on inside of Europe. And we've also seen a lot of coordination actions here. I think there's about 6 different roadmaps, white papers, and various things, all trying to define which way Europe should go in the future. So that's quite interesting as well. I'm sort of involved in a variety of things, sort of base 2020 and also Framework 9 at the minute. Interesting stuff moving. But it's quite interesting to see all of these different roadmaps. And I think the key thing is really a lot of synergies between these roadmaps as well. So I can see a number of things that you're coming across. So Werner Steinvogel spoke about the drivers behind digital strategy in Europe. The thing which are coming, autonomous driving, smart factory, healthy ageing, are all key topics for Europe. And there's a big push for this leadership in digital value chains, and this trying to get the technology into the different members of the value chain. The large companies in Europe are very good at already adopting these technologies. It's actually trying to get it down through the value chain and get it into the SMEs and the mid-caps as well. This is one of the big worries for the Commission at the moment. And also skilling the workforce for digital change, and also trying to ease things by adapting legislation, looking at privacy, looking at autonomous driving and things like that, trying to come up with harmonisation in those to try and make it possible for companies to exploit the technologies. Now, one thing that Werner mentioned was less money for smaller projects and more money for larger projects now, and that's very much the case. So there's been quite a concentration on public-private partnerships with things like Excel, which is very large, multi-billion euro program. We've also seen there's a big push towards European leadership in platforms. So before Christmas, we were actually in a lot of meetings about platforms, and really there's an opportunity there for Europe. And in particular, there's a lot of interest in large-scale pilots and test beds, and also innovation projects actually to reach out to the SMEs. And the key message really is that really the Commission wants to work in partnership with industry, but also with member states and regions. So it's not just money coming in from the Commission, it's also money coming in from industry and also from the member states as well. So it's tripartite. So Excel, for instance, is a tripartite public-private partnership. Okay, so we heard from SmartCPS, who jointly organised the event today, and here they've looked at roadmaps and implications of the 60 building under these 3 pillars. Very interesting to see that they've analysed 72 projects. That's an awful lot of work. I appreciate that greatly. And also, it's very good that a tool was developed. I'd love for it to actually help with this. I think that's something which should be exploited in the future. The interesting thing coming out of this is actually that as companies face challenges, actually there's a lot of synergy in
whole way we can deal with systems now has to change from the existing ways that things are done at the moment. So there is a big opportunity there. We also need more access to joint test beds, and so that's an opportunity particularly for SMEs. Human factors need to be considered in modelling for situation awareness, and there's a lot of problems with structural barriers at the moment, and those are maybe getting worse at the moment, but we shall see what happens. And also the other thing is, it was quite interesting that 4 test cases were identified where collaboration may be possible. So I think that's important to actually put forward the topics which are important. SCORPIUS project has really been driven by, okay, Europe needs to think about using ICT to actually get more efficient in view of competition from low-wage countries. And quite interesting to see that here they looked at, went through 120 interviews with people, where can ICT be used within the industry? And I think that's an important outcome there as well. The roadmap has come up with 6 clusters, looking at things like data for business models, for improved products, those with manufacturing, to produce efficiency in digital economics. And I quite like the way they've put together these context factors and also these technology enablers. And the problem is how we glue those together. So we've currently got this jigsaw puzzle, and we need to glue those together. And what they've done is they've created these 14 priorities identified in their white paper, which actually provides a glue between those two and hopefully solves the problem. Okay, Hypebeak. Now, I always like Hypebeak when they present because they always introduce me to new terms which I've not come across before. So we've got cyber-physical entanglement, which is a new term I've not come across before. The idea that computers are disappearing from view and we're mixing the cyber and physical worlds, and basically our cars become a smartphone on wheels. And also the idea of the sensor era as well. So the idea that, okay, artificial intelligence is becoming more important, and we are increasingly interacting with our devices via sound technologies. So the interfaces are changing as well. And the other concept was the Internet of Threats as well, which is another concept I quite like. Okay, so there's challenges here as well in terms of security, privacy and safety, particularly for mixed criticality, and we need to develop trust in machines. We need to be able to guarantee safety, and that's for both functional and non-functional properties like timing and reliability, and we need to be able to deal with the design techniques, particularly if we're trying to put together systems which are made of reliable and unreliable parts, and that is the challenge for the future. Transforming data into information as soon as possible is another key thing. What we're doing is okay. Oh, that's right. Okay. So transforming data into information as soon as possible is important, also transduction as well. So one approach which we talk about a lot, people talk about cloud computing at the moment and the use of supercomputers, is we're connecting everything to the cloud, and of course that works for some things, but it doesn't work for things that we're talking about autonomous cars, because autonomous cars won't be connected all the time, and they're safety critical. So there's also a move towards local processing or edge processing or edge computing as people talk about, and of course that introduces its own limits as well. So this is becoming increasingly important, but it also introduces elderly people. The message here, we need to work software together, we can't consider them in isolation, and energy efficiency will be a major challenge for the coming years, particularly with more mobile devices. And we also need AI by human designers to help master the complexity. And the key message really was that we need to reinvent computing. So it's a big opportunity and a big challenge at the same time. CPS is addressing really the practical issues of trying to deal with systems where we can't predict what they're going to do. And at the moment we're trying to verify systems where we don't know quite what they're going to do. So to produce formal guarantees that they're safe is quite a problem. So you can imagine there's lots of these automotive applications. It's not possible to consider every single outcome or every single situation. Also, quite interesting to see the idea of K-box as well. I'm sure they have lots of sandwiches when they're developing their systems. So a number of instructors for this, but really the key message really is that they have some interesting applications which need this. So automated vehicles, human robot planning, manufacturing, wind turbines and smart grids. But really their approach is quite interesting, using see that they received over 100 proposals, so that's quite a lot of proposals which were received. This shows that there is a demand for this sort of action, and actually it'd be nice to have more of them. And platforms were being used in a number of different applications: autonomous vehicles, aerospace applications, maritime projects, and also in smart cities. So the applications are very relevant as well. Okay, SmartCPS is sort of similar, but it's looking at providing technical platforms across 9 countries, and they have a range of different platforms, ranging from software platforms to integration systems to also hardware supplies. But they also provide coaching and development plan definition and also some help with service review. And here they've had 3 open calls, and again they've had 118 proposals, and they've funded 34 of these in a mixture of smart topics. So the other message here is actually you get a lot of proposals, actually your chances of success are quite high. It's about 1 in 3. So it's quite a good scheme for SMEs. Okay, SCORPIUS. This is something that sort of came out of Artemis, and basically it's translated this European-wide interoperability specification. The big problem really is that when you're trying to develop complex systems like aircraft, you use lots of different design tools together, and none of them are interoperable. And so we want to try and connect hundreds or thousands of software tools together to actually develop a system. And you can see that it's quite a complicated process to try and connect all these different tools together. So a number of projects went before: CSER, NMAP, Crystal, and Leaders, and they all developed various parts of this. But basically, the aim of this project is really focused on developing standardization around the iOS for this. And as was said, the problem really is that it's not easy to map to a single standardization model. So how do you get that in? Someone mentioned de facto standard this morning. I think this is one of the cases where a de facto standard for tool interoperability is something which is maybe the way to go. And the other thing really is they have this iOS coordination forum, which I think is also a very powerful thing to do. Okay, that's the wrong way. Okay, the eyes of things, EOT. This is really considering the smart everywhere concept, and the idea that actually we want more complex sensors in the future and really moving towards vision sensors. It sort of fits with what high people are saying about the interaction with systems. And here the key thing really is to try and come up with something which can do the processing, which is lightweight and low power. And so they've been developing this board, which is quite impressive. And the real key thing is trying to do get the maximum amount of information for the minimum out of this system. And there's a number of interesting applications there with the doll for children, the people on camera, live logging, and the museum audio guide. And of course, I think there's lots of other potential applications for this, particularly in the automotive sector, which I can think of. Okay. Now, Roland Rosen from Siemens talked about the customer benefits of cyber physical systems. And this is really sort of tying what the Commission is saying as well, is actually it's more about how do we link people together and what are the benefits of these systems for people. So the message was that with digitalisation, we've got lots of zettabytes in the future, 50 billion connected devices, and it's changing the way we do business in the future. Everything's moving towards services and data, so how do we make money out of that? And we also need to think about how it changes the way we develop things as well. So we're moving towards virtual prototypes. There's more connectivity, we're using that for monitoring and access. We talk about digital twinning now, we talk about plug and operate, and we've got lots more communications and connectivity. tools which they have incorporated this with power consumption, and also they're developing security tools in this as well. And the other interesting thing coming out of this is actually they're setting up a spin-off to support the tool. So this is sort of promoting the technology to move it out into the marketplace, which is important. Into CPS, I notice their logo is pretty much what their project is doing, what their project is doing in the corner. But the aim of this is to create an integrated tool chain for model-based design of scientific systems with a number of objectives, but basically looking at multiple modelling paradigms in here and looking at co-simulation systems, which is very, very important. They have a number of applications in the automotive, agricultural, railway and building automation sector, not just engaging with the large companies, but also with the SMEs and bringing all of the key actors together. CPS Summit, as was mentioned, CPS Summit finished last year. I don't remember when exactly last year, about October time last year, September, October time. And what it did was actually run a number of workshops between the EU and the US, where a number of ideas were discussed, where people could work together. And I think what it did do is really raise awareness between the EU and the US that actually there's a willingness for people to work together. It's just a matter of trying to identify how people work together, what subjects are the ones which are most interesting to both sides of it, and also how do we get past some of the barriers which are there, and do we need a large initiative with lots of investment, or do we do it in a smaller way and with mobility researchers? And there's different approaches to this depending on how much political will you've got to actually support this. Okay, to summarise all of that, we talked about industry engagement via Artemis and the strategic research agenda. Industry is very interested in tool chains, and so we find this project supporting the tool chain development in terms of into CPS and server area here. V&V was mentioned as a hot topic on the TAMS roadmap, and again, it is for industry in general, so here there's lots of interest in unifying control and verification of technical and service systems, which is really targeting the way things are moving. That we're moving away from the way we normally do this to ways where we can't do it in existing ways of trying to do certification, so we need to do something new and radical. Interoperability is important as well to try and connect all these different tools together. In terms of the projects we've seen here, we've seen a mixture of different things. We've seen sensing in terms of the EOT, eyes everywhere. We've seen data in terms of Bond's eyes, with deep learning AI data marketplace. We've also seen autonomy with CPS Swarm, with collaborative autonomous CPS. And these are probably some of the hot topics which I've noticed which are coming out at the moment. We've also seen Siemens talking about their interest in deep artificial intelligence, digital twinning, autonomous systems, and simulation. So there's some synergy there. But also highlighting the fact that safety, security, and human interaction are important as well. We've also seen projects on hardware and software, directly addressing how we speed up hardware and get the best performance from hardware. We've also seen simulators to try and simulate some physical systems as well. Safety and security, we've also seen projects there. So Sakura is looking at safety and security by design. We've also seen TAPS, which is looking at trusted applications. And then there's a whole raft of projects on this side, which is looking at engaging with the community. So there's been a shift, partly from the technologies to actually engaging with the community. Outreach to SMEs, EuroCPS and C60 Labs have done a very good job of actually engaging with SMEs and getting projects going. Roadmaps, there's been a number of roadmaps which have been projects in terms of Road to CPS, SCORPIUS, Platforms to CPS is a new one, and IP. And the good news is there's a lot of synergy between those. It's a matter of how we bring all of that together to influence the Commission in the future. And in terms of engaging with the US, again, there's some interesting ideas being put forward, particularly in the areas of modelling and simulation, where there's opportunities for people to work together, particularly in areas which are pre-competitive. Okay, so how does this fit in with what the European Commission are doing? Well, the big news really is that digitisation is the thing which is pushing everything. The big concern at the moment is this fragmentation across Europe, and the skills aren't there. And so a number of these projects are actually looking at trying to get those skills to people. We've got quite a few different roadmaps. I can see some overlap with those. Some of them are a bit more sector specific, particularly for the manufacturing area. We've also done some industry views, looking at Industry 3.0. Areas not addressed today, I'm trying to think what they were. The question did come up about scalability. So quite often we talk about developing this system, but actually the real world is getting more complex very, very rapidly. We talked about 50 billion devices, 44 terabytes of information flying around. So there's a lot of interest in can we do demonstrations at scale. Connecting SMEs at the regional level, giving them access to technology. Part of it is actually connecting to the SMEs, and part of it is actually raising the awareness. And there's another push also in trying to engage with the non-technical sectors as well. So there's a big push in things like agri areas, so trying to get farmers interested in technology, which is quite a challenge. So skilling the workforce for digital transformation is an issue, and also supporting legislation, so data privacy rules which are coming in next year, and also rules for autonomous driving, which are important as well. So I'll finish off with a number of key questions, just I think.
First of all, I think we can have the applause. These are the questions to discuss. So maybe just a comment from my side. This is kind of, you've seen how we can condense all what has been said today on one slide. So it's kind of making use of big data. For the big data in your heads, I believe you will need some beers tonight to get all of that out of your head again. But I think this is now to really start a little bit of discussion with the audience already. So, of course, up to you also if you're still ready to do that. It's kind of later than the time we expected to be finishing. But I think it is worthwhile for everybody who wants to discuss questions. I think we should do that now. That's the kind of interactive path we still could have. So maybe, yeah, you can go through those questions.
I think the three main questions. The first one is every research plan. So we've seen a number of roadmaps today, and 6 of them have some recommendations. Are there any gaps or anything missing that someone wants to jump and say, actually, why haven't we included that? Some of the things I think about are like cognitive systems and societal socio-technical issues, which I think are mentioned in roadmaps, but how we engage with those I'm not quite sure. Also, are there any ideas for cooperation across projects and the program? So, how does the project we've seen today link with things like digital platforms? Is there anything which could be offered by the digital innovation hub in the outreach projects, which would be of interest to industry? And also, what are the barriers to industry? And what can EEC do to help in that area? So, there's things like developing trust, raising awareness of the public, regulations, etc., and standards. But are there other things the Commission could do, and how do we go about doing that? Should the Commission be involved in standards? Is one of the questions, or should it be done by industry? So if you want to address the first one first, is there any burning topic which hasn't been talked about today? We've talked about an awful lot of things, but is there something there which you think would have been missed, which you think should also be there on the topic?
Everything was covered?
If you wanted a focus for the future, what do you think the focus for the future should be? The current focus is very much toward platform, and will be for the next 4 years, and a lot of the funding will move into larger projects. Do you think that's the right focus, or do you think there should still be a focus on small projects as well? certainly need this application validation for establishing the bypass as a payment. And this doesn't seem to be touched on any of that.
Yes, hi. Thank you very much. I don't know how you can do it. Of course, you are very professional doing this summary. My point of view is the same one. I think that the current case studies in labs projects and ongoing projects are still symbols to guarantee that the method that we are developing or have been developed can be extended. And this is exactly what I think about it. I think that it's necessary to explore, as you mentioned, more complex case studies in order to guarantee that just from the design we can guarantee that later these kind of methods that we are developing can be extended. This is basically my point. I don't know.
So, right now there is a huge battle in the United States to get a piece of the IoT. I mean, all the companies, big companies are working on that. Google, Apple, Microsoft, IBM, you name it. I haven't heard much about that here, and so there are not many companies that are doing this in Europe, and who is making the platform for IoT is going to be the...
I think I can answer that question because I'm involved in the IoT side of the commission as well. So the commission has a whole unit that was set up mid last year that covers IoT now, and it's pure, its sole goal is IoT. And there's a lot of interesting platforms. They've done an analysis, and there are over 360 platforms out there.
No, you just did one.
Yeah, I know.
The
message is that the Commission don't want to develop a new platform. What they want to do is see which platforms survive in the marketplace. And the key interest really in federation platforms, how you connect them together. Because the other thing you
No,
find...
you're going to lose, Europe is going to lose the battle again. They lost the battle of the internet. Now if they lose the battle of the IoT, everything is going to dominate it. Again, the marketplace is going to make it US.
But the reality is that when you talk to the smart cities people, if you talk to the mayors of cities and the people who govern cities, they don't want to go with one particular solution for this. They don't want the Google solution. They don't want the
there is no European. What is one European solution?
So what they want is to be able to mix and match and don't get vendor locking, which is why there's a lot of interest in federated platforms at the moment to allow people to get access to these markets and make sure that they're not dominated by the big American companies. So there is quite a push at the minute to try and work out how we federate platforms and connect them together. So there's not money to develop new platforms. So Fireware is a big initiative to develop a new platform. There's not going to be something like that together, I don't think. What we're looking at is trying to connect different platforms together. And in particular, it allows SMEs
What
to
do you
get
mean
into
by
that
platform?
marketplace.
What do you mean by platform? Because I hear all the time the name platform.
Yeah.
So what do you mean by platform?
Yeah, there's different levels of platform. In Europe, we're very good at platforms for connectivity, which is wrong because the Americans are very good at platforms for connectivity and data aggregation. And the more money can be made out of the aggregation side of things, where you're actually dealing with data and where the added value is. And so Europe does have a particular strength in embedded intelligence and also in the networking side of things. And out of that, the interesting thing is, we heard it today as well, is that the move is towards edge computing. So the big companies of the world are considering cloud computing. So they move everything to the cloud, they do the number crunching and get the data back. Actually, the future is more towards edge computing. Europe is very, very good. 30% of the embedded system market is actually held by Europe, and we're very good at processors and doing the embedded computing side of things. So there's a big opportunity for Europe to capture that market and try and move the intelligence down to the edge of these systems. And so the data aggregation will be done locally, and it's the only way we can do it for autonomous car vehicles. There's no way we can transfer all the data we need to back to the cloud by the network.
You can put it in the fog.
Yeah.
In the real-time fog.
Yeah, no, but we won't have the fog available everywhere.
No, but I mean, what is the internet? It's a real-time fog. I mean, you can put it there.
Yeah, you'll have it available in cities, but it won't be available all around Europe. There are areas where connectivity
just want to reflect on your very first question first, and then go back to the point that you made. So, if we're talking about the commission-sponsored projects, so have we got every priority covered? In a way, I'd say we've got too many priorities covered there. And what we should be looking at is, what could we take out of the sponsorship at government level and push it into industry so that we can move faster on some of the other areas? And your point about platforms is very well made, because the platforms are created by commercial organisations. They've already won. Okay, there's not a competition there anymore. They've already done it. And that hasn't been because of government investment, it's been because of industry investment. So what are the areas that we could take out of the agendas and say, actually industry, you can do that, just get on with it. And where should we focus where we can accelerate for Europe and if you like, steal a march in time?
This is why there's such this concentration on federated platforms. We know there's lots of platforms available, and we know that people don't want to be locked in with specific vendors. So the idea would be to make sure we get them interoperable so we can actually talk between platforms. And that opens up opportunities for SMEs, for instance, because at the minute they get locked out straight away by the large companies. And also it's of interest to the people who are buying these systems. If you talk to the people who operate in cities, they don't want to be reliant on Cisco or IBM or whoever is supplying these systems. They want to be able to mix and match. So it's important to have that freedom to be able to change.
That probably comes at a cost.
Yes.
Yeah.
This is what the point is, that we need flagship companies able to, and this is eventually what we don't have these flagship companies we can set up, SMEs can, and this is what we don't have. And the problem in the US, there are these flagship companies. What we need is that, in comparison with the semiconductor industry at European level, we need equivalent flagship companies in order to able to create a business ecosystem around this. And when we have this kind of project with this flagship company, we will find this kind of. And this is one gap that we have to, from my point of view.